And we have the tunage going as well.
Sweet.
Just barely hear it. You need like a feed that goes directly in rather than through your microphone.
Yeah. I can hear it, but then again, I'm in the room.
True. I was doing that earlier, and I'm not sure how it comes through this
Yeah.
little mic either. So.
Well, I know with this, I changed my settings on the microphone to take the sound from all directions, and then when I'm talking, I can change the settings so it's just.
I could do that too,
Yeah.
can't I? Here.
I believe you can.
There.
That's better.
Did any of you ever go to a toga party?
No.
That doesn't surprise me. Did you go to a toga party, Dave?
Have I? Yeah. And people told me I had a good time.
What's a toga party? Come on, Gene. I know you know what a toga party is. And no, Chuck, no rock pile tonight. It's Animal House. All right. Well, hey, it's 7 o'clock. We should get started, huh?
I guess
That's
so.
beyond
Wow.
time.
That went fast. Toga, toga.
Toga, toga.
No, Mr. Ascot does not do toga parties.
All righty. Welcome, my friends, to part 8 of Takeo After Dark. How you guys doing? Good to see you all. Good to see you too. Now they're quiet. They couldn't shut them up earlier. Now they're both getting shy. I don't know. Yes,
I don't want
to
to step on you. You try not to step on people. So
That's right. That's right. Okay. Well, no, that's you got to just jump in. You got to jump in. And all the Animal House is coming in. Are we on double secret probation? And Richard McGrath. Actually, that's a direct quote from what my father said to me the day I left for college. It was fat, drunk, and stupid is no way to go through life, son. And then this is this shirt actually reflects my first 3 years grade point average, 0.0. All righty. Let's get through this. Welcome everybody. Glad you're here for part 8 of Takeo After Dark. We were just discussing this. I think we've got a couple more sessions here that we're going to go through, and then a couple more sessions, and then we're going to figure out what we're going to do after that. You guys can kind of give us a little hint of what you would like to see us do. I've got Tim Ward and John Messenbrink. John, I'd like to say hello to everybody out there in webinar land.
Hello, everybody. Yeah, Dan Cook had asked a question. Will you gents be continuing this? So it's something we had just talked about. So love to know what the audience feels about that, because we'd love to do it. Keep doing it.
You guys tell us what you want. If you would like to see Takeo After Dark going on for a while through the summer, I mean, what else are we going to do? Where are we going to go? I mean, it's not like there's a whole lot of other stuff to do out there on Wednesday nights for a while. So, well, we got a couple of we want mores. Was it over when the Germans bombed Pearl Harbor? Hell no. So it ain't over now. All right. So okay, I think you got a little consensus there, John. Maybe we can get into some discussions there. All right. Excellent. I'd like to see you, Takeo, come out west for a round of golf. Andy DeGraff, nothing would please me more. Let me tell you that. Nothing would please me more. All righty.
Mr. Wheels, you'll get it.
You'll get your eye valves sooner rather than later, Steve. Patience, grasshopper, patience. All righty. Tonight we're going to be talking about all kinds of cool stuff for Takeo After Dark. Basically, part 8, we're going to be talking about mod cons. We're going to be talking about buffer tanks, and we're going to be talking about how zoning impacts both of these things. Zoning impacts buffer tanks and the need for mod cons. So we're going to go through all this. And we got a question from Russell Beck. Does it matter that you missed last week? No, it doesn't matter that you missed last week. but hey, last week we gave everybody the secret to making $1 million in this business the first year. You missed it. I'm sorry. Hey, we'll get okay. We'll do all right. But
And we turned the recording off at that point too.
and we turned the recording off, so there's no evidence of it anywhere. But no, not at all. Again, if you go to Mechanical Hub's YouTube page, Russell, you can watch all of the previous sessions. If you go to Taco's YouTube page as well, you can watch the previous sessions. So they're all recorded and they're there for you. So don't worry. All the material is there, and each one of these I think will stand alone. They build on the one previous to it, but I think they'll all stand alone as well. All righty, let's get rolling on to part 8. And actually, before we hit part 8, I just want to do a quick recap on part 7 last week. What did we talk about last week? Well, we discussed the incredible shrinking delta T and the importance of that and how that happens. And that it's not a good thing that the delta T shrinks like this. It's just when you use a circulator, and the more oversized the circulator, the worse the problem is. The delta T is going to get smaller and smaller as it gets warmer and warmer out, and that's going to lead to greater and greater short cycling, right? That's going to lead to short cycling, which kills efficiency. And if we went through a couple of examples of using the typical, your typical 3-speed circulator that's out there in the market, whether it's the Taco 0015 standard efficiency version, whether it's the Grundfos 1558, the NRF 22. They're all too much pump, people, for most of what we're doing. For a lot of what we're doing, just way too much pump. And you're going to see some of that tonight as well. And when you do that, when you set it to speed 3, contractor no callback mode, you make this problem even worse. All right. And you may find that we're in, for half of the heating season, or maybe more than half of the heating season, we have delta T's less than 5, and it's no wonder boilers short cycle, and no wonder parts and pieces and moving components wear out ahead of time. So that's just kind of the way all that works. And we talked about how do variable speed circulators help this. They do to varying degrees. A delta T circulator can help it to a greater degree. A delta P circulator, if you know how to program it properly, and there's no magic push button there, if you know how to program a delta P circulator properly, it can help as well. And we talked about maybe the most versatile circulator out there, the 0018E variable speed circulator with Bluetooth connectivity. And we did a little demonstration with that. Dave had it set up in the background, and you're able to see it in action. So that was pretty cool. And so we talked about that as well. Now, this week, as we said, we're going to be talking about ModCon boilers. We're going to talk about piping them and pumping them, and we're going to talk about doing it the right way and simply. This isn't a complicated thing here. It can be done very simply and very easily if you understand just a handful of simple basics. All right, handful of simple basics, and we'll work on it from there. And we're also going to talk about microzones and how microzones make things like buffer tanks a lot more sensible. All right, a lot easier to deal with. Okay, and helpful. So we're going to talk about that. And we'll talk about how to size a buffer tank as well. So let's get to work. All right, let's get to work. Mr. Blutarski, 0.0. But hey, he became a United States Senator, so there's that. All right. So let's talk about ModCons, let's talk about water temperature, and let's talk about piping, and we're going to explain it simply. You're not going to try to overload you with stuff. There's going to be a little math here that on the looks of it might freak you out, but trust me, it's stuff you mastered by 5th grade that as long as you understand what we're trying to do, the math is actually pretty simple. So with that, let's talk about some ModCon basics, and so simple a child could do it. Your basic piping strategy, everybody knows this, it's primary, secondary with a bit of a twist. All right. Typically, back in the days when we were piping up cast iron boilers in a primary, secondary manner, you had a primary loop on that cast iron boiler, and that primary loop connected the Gazauta hole all the way around back to the Gazinda hole. It was basically an extension of the boiler. All right, and then that was your primary loop, and then you had your secondaries taken off of that, 6 inches or 4 pipe diameter closely spaced T's, a supply and return for this load, a supply and return for that load, and a supply and return for another load. And they had cascading water temperatures. You started with the highest water temperature radiation first, then the next highest, and then the lowest, the middle one and the lowest. But the point behind that primary loop, the whole point behind the primary loop was to protect the boiler from low return water temperatures, to protect the boiler from flue gas condensation. The whole thing was designed to do that. It was designed to make multi-temperature, multi-load systems easily piped, which it did, but it was also allowed you to do that while protecting the boiler from low return water temperatures and flue gas condensation. Now with ModCon boilers, we don't got to do that, all right? We don't have to do that. There's no need to protect the boiler at all. In fact, we want to abuse the boiler with low return water temperatures. The more we abuse that boiler with low return water temperatures, the more it will reward us with greater efficiency. I mean, it's pretty simple stuff. So we want to, there's certain ways to do this. You can do a primary loop and have the boiler as a kind of a BTU injection device into that primary loop. But more commonly, we do something kind of like this. We have to take into account a high head loss heat exchanger. We take into account there's no need to protect the boiler, and we have two separate loops. And it'll look it's kind of like this. We call this moose-antler piping, all right? With moose-antler piping, you have your boiler loop right here. You have your heat delivery or your radiation loop right here. So you've got those two different loops, but it looks like moose-antler piping, for obvious reasons, all right? So the boiler loop and the heating loop, I call them the boiler loop and the heating loop. Now, a couple of fundamentals here, usually, and this isn't all the time, and Rick can explain some of the finer nuances of this, but not all the time, but usually the boiler circulator pumps into the boiler's heat exchanger. This isn't a pumping away thing. I've got my pumping away thing here. At the boiler, we're pumping into the boiler's heat exchanger to keep the pressure up in the boiler, because under certain conditions, you may, in fact, when you're firing up to really high temperatures, maybe to make domestic hot water or something, that maybe if we had the pump on the other side, you could lower the pressure in that boiler to the point where maybe that boiler may happen to flash to steam. And when it flashes to steam, it makes a hell of a racket, all right? The good news is it will eventually stop making noise, but it's going to stop making all kinds of noise. It's going to stop doing everything after a while, but at least it won't be making noise. So we've got the boiler circulator here, and then you have your system circulator over here. Now the thing about ModCons, and Rick will get into this, is ModCon boiler piping, and we've got some folks from NTI on, and we've got some folks from Wa-McLean on, and other boiler companies. And I think they'll bear this out. Piping up a ModCon boiler may in fact be the easiest thing on the planet to do, right? It may in fact be super duper simple, because you know what every boiler manufacturer sends with the boiler? They send a book, all right, a little booklet. And you know what's in that booklet? Rick, what's in that booklet? Dave, what's in that book?
Pictures.
How to make it. Pictures. They're 1,000 words.
Pictures
Drawings.
Pictures worth 1,000 words. They tell you how to pipe it up. All you got to do is look at what they print and do that. All right. ModCon, very, very simple to do. They'll even tell you what size this pipe should be, and they'll give you some ideas about that pump. All right. I mean, how easy can it be? How easy can it be? And one thing we have learned about ModCon boiler piping is ModCon boilers do not reward your piping creativity. All right. This is one of those things. Don't get creative, man. Do what it says in the book and you'll be fine. Now we're going to show you some different looks at this thing, but basically what you see here, do in the field. All right. All right. And Rick will be discussing this type of piping here in a little bit. You'll notice on this particular drawing, we have there's a Takeo 4900 dirt mag separator on the return side. That's done to protect the boiler, okay, to keep sediment from gathering in the boiler. And then you have your air separator and your point of no pressure change connection on the supply with the circulator, the system circulator pumping away. And then right here, we've got a little power purge station. You'll notice there's a ball valve and a drain cock right there. So you can actually power purge to your entire system doing it that way. So there's some interesting things here that Rick put into this drawing for you to take note of. All righty. If you have an indirect, same thing, only different. Now we have an indirect in the picture. And the thing to remember with an indirect is we want to take the supply off here, all right? And the return comes back after this circulator. So the return pump is pumping into the heat exchanger like so. What this does is it avoids us having two circulators in series, all right? If this had been returned right here into this point, now I might have two pumps working in series, which we may not want. All right. This keeps things separate, keeps things simple. Now they're in parallel as opposed to series. And we dedicate that circulator to the heat exchanger in the indirect and through the heat exchanger in the ModCon. All right. If we had a hydraulic separator, which is simply a hydraulic separator, there's a lot of interesting things that can be done in a hydraulic separator. But basically what it is, it's a big open space in the piping. All right. In simple terms, it's this piping done for you. All right. And in the simplest terms. Now you can use this as a velocity slows down. It can be an effective dirt separator. It can give you a little bit of air control here if you want it to. I mean, it can do all that sort of thing as far as we're concerned on the system, as far as we're concerned. But it adds a little bit of mass. Now there are going to be instances where you will want to do this, this piping scenario. There will be instances where you want to do this piping scenario, and there will be instances where you will want to look at a buffer tank. And we'll discuss that a little bit later towards the end. All right. So let's talk about another thing that you can do with ModCons is mixing with the ModCon. This isn't the full-blown iValve discussion, Wheels. That's coming next week. But I just wanted to show you here that you may want to also have some mixing stations for lower water temperatures with a ModCon. Let's say you have a multi-temperature, multi-load delivery system. Now, what do we mean by multi-temperature, multi-load? All right, maybe I've got some high-temperature radiators, all right, that maybe I want to run 150, 160 degree water through under design conditions. And let's say I've got some between the floor joists radiant that maybe wants 140 degree water under design conditions. And then I got a basement slab that maybe wants 120 degree water under design conditions. Should I set it up so the same water temperature runs through each? This might be an instance where we might want to mix separately those two lower water temperatures. And here, this is an iValve. This is a Takeo iValve. It's either a 3-way or a 4-way motorized mixing valve. And in this little green motor is actually a fully functional outdoor reset control. You just connect an outdoor sensor, you connect a little strap-on sensor that goes onto the radiant supply, and you have a sensor outdoors, and you have fully functional outdoor reset. For this, you can have separate reset here, and you can have a separate reset here. Each one of these will have their own outdoor sensor and an own supply sensor. And the beautiful thing is, well, let's think about that. If you were to reset off of the reset, which is what we're talking about here, if you reset off of the reset, they're not fighting with each other. Remember this, they're not going to be fighting with each other because the boiler is resetting on its own schedule as well for that high temperature radiation. What do you think? And type in your thoughts here in the question section, guys. What do you think the benefit would be of resetting off the reset in two stages? I mean, a mid temperature and a low temperature reset off of the higher temperature reset that the boiler is doing. Type in what you think it might be, guys. This will be an interesting take. What would be the benefit? And what do we have?
According to Wheels, love.
Very good, very good. Yeah, you guys all got it. You're in both instances, you have the ability to send even colder or lower water temperatures back to the boiler than it would be getting anyway. So again, the more you abuse these things with low return water temperatures, the more they reward you with love and efficiency. Okay. No, time travel isn't it, Bill?
Yeah. Time travel.
Time travel. You know how we know time travel has not been invented yet? Because ain't nobody come back from the future. You know, no one's come back from the future to say, hey, watch out for this virus. So they haven't invented it in the future yet either. Or maybe that's just not the right way to look at it. I don't know.
You're
But,
getting
They
out.
didn't want to come back to bring it back to the future.
Yeah, I tell you, if I invented time travel and I could go back to any year I want, you sure as heck know I ain't coming back to 2020. Not gonna happen. All right. So yeah, you guys get it. We send lower and lower water temperatures back to the boiler, and that makes boilers very, very happy. Now here's a little math brain teaser for you. Now here's a little brain teaser for you. I've got a system here. All right, 70,000 BTUs. All right, 70,000. My load is 70,000 BTUs. That at a 20-degree delta T, that's going to be 7 gallons a minute. And my radiation requires 150 degrees under design conditions. All right. So I've got 7 gallons a minute of 150 degree water going out. That means I also have 7.5 gallons, or 7 gallons a minute rather, 7 gallons a minute of 130 degree water coming back. So 150 going out, 130 coming back. I got 7 going out. Unless something really bad happens, I should have 7 coming back. All right. My boiler has a required flow rate of 4.5 gallons per minute. So I've got 7 gallons a minute coming here to this first tee. When this circulator comes on, I'm yanking 4.5 gallons a minute out of that loop, out of that delivery loop, to go back into the boiler to be reheated and to come back and join that water just a few inches down the path. Now the question is, what water temperature does the boiler need to make so this system will work? Type in what you think here in the question section. What temperature does the boiler need to make in order to get my 7 gallons at $1.50? All right, I'll give you a hint. It ain't $1.50. All right, it's not 150 degrees. If you set that boiler up to make 150 degree water, we're not going to have 150 degree water going out to the system. It's just not going to work. All right. So let's see what we have here. Let's see if anybody came up with an interesting. So yeah, we got a bunch of guesses here. We got a bunch of guesses. Good. All right. Very good. Well, there's a way to know this, and there's a way to guess. Guessing is inference. Guessing is inference, but knowing is simple arithmetic. Knowing is simple arithmetic. All right, let's do one. Here's the math formula. All right, FA times TA plus FB times TB equals FC times TC. Now, who here is kind of looks at that and go, what the heck? I was told there'd be no math. No. This is science, man. Hydronics is science. Of course there's math. But does this math formula freak you out at all? That's a question I'd like you. Does this freak you out? It's algebra, man. Remember 7th grade, and you were learning algebra in 7th grade math class, and you're thinking to yourself, this is ridiculous. This is BS. I'm never going to use this in the real world, like ever, man. This is a waste of my valuable 6th or 7th grade day. There's so many other more important things I could be doing than learning algebra. And people have gone, I've seen them on Facebook all the time. Yet another day has gone by and I haven't used algebra. Well, that's because they're not in the heating business. There's algebra here, folks, and it's pretty simple stuff. All you got to do is know what you're talking about. We're in the heating business, right? We're in the heating business. Type this into your question section. If you're in the heating business, if you're in the hydronic heating business, what do you suppose F and T represent? What do you think? I mean, this is about as common sense as we get. What do you think F and T stands for? Right? Yeah, flow and temperature. But of course, flow and temperature. So the flow of A times the temperature of A plus the flow of B times the temperature of B equals the flow of C times the temperature of C. What we have here, ladies and gentlemen, is a simple 3-way mixing formula. All right. Let's think about what we're trying to mix here. Let's think about what we're trying to mix. What we have, first let's identify the terms, all right? We fill in what we know and we simply solve for X, all right? So let's see what we have here. Well, if we understand that we're looking for what's coming out of here, right? We're looking for what's coming out of this mix point here. Well, we got to understand that I'm going to be mixing whatever's in this little hunk of pipe. whatever flow and temperature is in that little hunk of pipe between the T's is going to be mixing with whatever comes out of the boiler. It's going to mix right here and give us the flow and temperature through C. Now we know what the flow and temperature through C is. We know it's that. Okay, so we know A plus B equals C. So it's the flow and temperature right here versus plus the flow and temperature here equals the flow and temperature here. So we know most of those numbers, all right? That's 6 numbers, and we know 5 of them. We've got this sucker in our sights, man. So let's fill in what we know. All right, let's fill in what we know. I've got 7 gallons a minute of 130-degree water entering this first T. I'm yanking out 4.5 gallons a minute of 130-degree water. So what do I have left in A? Well, 7 minus 4.5, that leaves me with 2.5 gallons a minute in this pipe, 2.5 gallons a minute. And at what temperature? Well, it's got to be 130. So 2.5 times 130. What have I got coming back from the boiler? Well, it's got to be 4.5 gallons, right? But I don't know the temperature. That's what I'm trying to find out. So that's X. And then out here, I already know I've got 7 at 150. So now we just multiply. 2.5 times 130 is 325. 7 times 150 is 1050. And 4.5 times X is 4.5X. Now we have to isolate for X. First thing we're going to do, again, basic algebra, we got to make these two sides equal out. So I've got an extra 325 here. I want to subtract 325 from that side. But to do that, I also have to subtract 325 from that side. So if I subtract 325 from both sides, now I have 4.5x equals 725. Then I divide both sides by 4.5 to isolate and solve for x. I'm going to need about 161-degree water. All right. So that's a simple 3-way mixing formula that you can use in a whole bunch of different applications. But now we know this boiler is going to have to make 161-degree water in order for this system to work. All right. So just a good way to know. It's always better to know and know how to find out a number than it is to say, oh, it's going to be around that. It's going to be close to that or whatever. All right. Now, as Rick will tell you, there are a lot of boilers that will actually, you can put a sensor here and it'll help. It will adjust this mix to give you that. And you'll be able to, there are boilers that can do that. But if there are boilers that aren't, then you're going to need to know this little piece of information. So with that, Taco's trivia question of the night. And Taco, what do we have, Dave, for our trivia prize this evening? And did we pick a winner for last week?
No, I have, I don't know what the prize is for this week, but I do have the names for last week.
All righty.
And last week we had we had a black Taco hoodie and a Taco black hat also to go along with that.
Okay, and who won last week?
We didn't choose that. We're going to choose that right now.
Oh, I see. I see. Well, I'll tell you what. Let's ask the question now.
Okay. So you want to do this later?
We'll select the winner. Let's select the winner when we pick at the end. Let's do that.
You got it.
Does that work? We'll select last week's winner, and then we'll
tell them the answer
when we do the answer for this week's trivia question. There we go. This is simple stuff. It's good. Do you guys realize we've reversed this? You know, we have this down to an art. Really, we do.
Yes. We make it up as we go along.
Say what?
We make it up as we go along.
Absolutely. That's the story of most of my life. Now, the iconic Taco 007 circulator is far and away the #1 selling wet rotor circulator in North America. It's not even close. 007, there are more 007 sold than most every other wet rotor circulator put together. All right. They sell a ton of these things and have for years. It's been around since the mid to late 70s, I think. And the trivia question is, how did the 007 get its name? How did the 007 get its name? So type it in the question section, and we'll go through that. We'll collect all the right answers, and then we'll pick a winner at random. We'll pick a winner among those who had the right answer at random. There we go. So how did the 007 get its name? How did the 007 get its name? It's our trivia question of the night.
Some people were listening.
Some
Some answers are just a little too vague.
people.
Some have nailed it right off the bat.
There you go. There you go. Well, what we're going to do now is I'm giving you guys a treat. I'm going to shut up for a while. Hey, let the rejoicing begin. And turn the con over to the one and only Rick Mayo. And Rick is going to take you through some additional information on ModCon piping, and most importantly, ModCon pump sizing.
Yeah.
And
Can you
it's a
see my
lot of
screen?
Say what?
Can you see my screen?
Not yet. I haven't given it
Oh,
to
I
you.
thought you'd already done it. Hey.
No, I'm giving it to you right now. There you
Okay,
go.
you just
Make
let me
Rick
know. Can you see it?
the presenter.
Show
just
my
made you-
screen. Oh, it's asking me questions. So
Hey,
yeah.
hey, there it is.
Cool.
Now I see your screen.
All right. Now I have to get rid of all this other stuff. Right.
You just move that. You can just move out of the way.
Boom. Push that out of the way.
Yeah, there you
Don't
go.
need to see that. Okay. Good enough.
Right. Take it
Thank you,
away.
John. Thank you. Appreciate it. All right. Let's talk about this from the standpoint of boiler efficiency, right? We're talking about ModCon boilers and we're talking about the circulator. We're going to focus a lot on the sizing of that circulator and how that can actually help increase the boiler's efficiency. So let's talk about this circulator for the most part. And John covered a lot of the little notes and little nuances and stuff. We're going to dig into that some more as it relates to how these tees should be configured. And this, you folks will remember from a long time ago. When we were talking earlier, we were talking about the original cast iron boilers, and when they first were introduced, probably in the early 90s, to variable speed injection mixing, we got to know this thing called primary secondary. Up to that point, and unless you went back to the 50s, the 60s in commercial applications, it just wasn't that big a deal. But once we got to know this, people understood, okay, let's get those tees together if they paid attention anyway. And let's, on the boilers, just run it around in a circle. We got closely spaced tees and it comes back to itself. John had mentioned we were worried about sustained flue gas condensation, and we would watch what the return temperatures were if we had a sensor and if we had a control with an actuator that could actually give us the ability to protect the boiler. But this is not really what they show anymore. So I'm going to point you a lot at what the boiler manufacturer actually tells you to do. And as John has already mentioned, if it's not in the book, you probably should do what's in the book and keep yourself out of trouble. Okay. But everything I'm talking about still would apply to this circulator sizing if somebody was to do this. I know for a fact there's people out there that do their ModCons this way. And you know what? If you're buying ModCons from me, I'm not going to say anything other than as long as it's working for you, then keep on going. Okay. But for the most part, this is how they kind of show you what to do with them nowadays. So again, focusing on this circulator, primarily we're going to talk about this circulator being in a fixed speed application, okay, fixed speed. Well, that means that there's no communication between the boiler and the circulator. Some boilers do not have an output, a control signal for the circulator, and lots of us pump manufacturers don't make a pump small enough that has that little tiny input. Taco does have one. It's some of our older series that uses wave chopping as far as changing the speed, but we're yet to have the small little circulator. We got the medium-sized circulators and we got the big circulators that take a signal from a third party like a boiler manufacturer, building management. But these little pumps, sometimes they're hard to find, and you'll see what we mean by little when we get into doing the numbers with you. Okay. Now, some boiler manufacturers actually give you an output to the circulator. It's in the form typically of 0 to 10 volts DC. Some European manufacturers have a pulse width modulation signal. By the way, our newest little circulator, 0034E and the E Plus, take either. You get 0 to 10 or pulse width modulation. But understand that when I control the circulator here, this circulator with a signal, then it kind of holds hands with the boiler's firing rate. It's not exactly based on firing rate or fan speed. It's actually based on, a lot of times, temperature differential right across the heat exchanger. But what we're saying is, as a pump manufacturer, when we do this, we're actually handing the keys over to the boiler manufacturer and letting them run the pump. Okay, so it can be a good thing. So, keep your eyes peeled for that sort of thing as well. But primarily, we're going to talk about when you do not have that control signal. Okay. First off, let's go back a little bit, do a little review. What does primary, secondary actually do for us? Okay. Well, what we're doing is trying to keep these circulators hydraulically isolated from each other, right? The circulators we're talking about is the primary boiler pump and the system circulator, right? So the boiler pump and the system circulator, so they don't mess with each other. They should not affect one another. So in order to do that, we have to follow the primary, secondary rules, and we'll get into those in just a second. What it does is also keeps the pressure drop of the boiler's heat exchanger out of what the system pump has to do. Okay, so we don't have to include anything as far as pressure drops concerned if we pipe it primary, secondary for the system pump. So the system pump just no longer has to worry about what the boiler's pressure drop is. Okay, and as mentioned earlier, the boiler manufacturer can and may control the primary circulator speed. That's just something that may happen, doesn't happen all the time. We do have to look out for short cycling of the supply water. We'll show you some good pictures of this that kind of show you what we're talking about here. So it is a point of understanding what may happen. Basically heating the water up and sending it back to a modulating boiler is not a good thing. So we want to be careful of that. And most of the manufacturers that make residential boilers, a lot of their manuals will show this as a preferred method. What I mean is primary, secondary, that's what their pictures will show inside their manual. So again, do what the boiler manufacturer tells you, pipe it the way they want you to. These are just, what we're talking about are just general rules that are pretty much accepted within the industry. When we get into primary, secondary piping, the rules are simple. I like to say they're like the ABCs, and that's why I've laid it out this way. Okay, so primary, secondary rules are simple like this. Okay, let's look at the A note. These are notes. This A note here is depicted between these two T's here. What we're saying here is we want a maximum spacing of 4 pipe diameters. I would like you to forget about the notes from the standpoint of the rules and think about the concept here. This says maximum, not minimum, right? So the concept is to have those T's as close together as possible. Whatever's physically possible to do, get them that close together, not exceeding 4 pipe diameters of this, in this case, the secondary header, if this was the boiler, okay? So if you folks, I believe my camera is still on, and I'll show you something I do when I'm face to face with people about getting analogies in. Okay, so everybody give me the right hand thumbs up, and everybody give me the left hand thumbs up, and put your fist together with a bump like that, and see how much distance I have between my thumbs up, right? Consider these as T's, right? Putting them together. And I got a nice long distance before I get to any elbows or fittings or anything else, right? Nice long distance here, long distance here. Basically what you got is 2 T's butted together in the middle of a nice long piece of pipe. That's the concept that you want to stay with, hence this little picture here. Okay. Note B is actually two-way, I should say. We have a minimum amount of pipe diameters coming in, the flow's going this direction, right? So I want a distance a minimum of 8 pipe diameters. So if that was 2 inch, it would be a minimum of 16. So ideally and conceptually, we want this as long as possible, right? And so when we get to these two fittings, the flow is in a pattern that we're looking for, and I'll talk about that on the next slide. So as we get past these 2 T's, we don't need quite as long a distance based on the initial piping taking care of the the issue that we're trying to solve. Again, I'll talk about that on the next slide. So 4 pipe diameters downstream. So it's 8 and 4 are the rules, but the concept is still the same. Get as much straight pipe as you possibly can preceding this first tee, and as much as you can get downstream as well of the second tee. This C note, this thermal trapping, we'll talk about on the next slide. Here's the same rules together, just a slide I've used for years and years, talking about this pump here and the water coming out of this circulator. So right when it comes out of the circulator, what flow pattern do you think it's in? I want to show you what it's probably in, this plug flow pattern with fairly high velocity coming out. The velocity will be pretty much the same across this, but it's somewhat turbulated. It wouldn't be turbulent flow or what we called laminar flow per se, but it's coming out, and we want it to mellow out before it gets to that first tee. We want it to be in this long bullet flow pattern when it reaches this first tee. Once it gets there, then it's going to be the same across those 2 tees, other than whatever's mixing in here. And if this pump is sized appropriately, it won't really turbulate this that much. It does a little bit, but like we said, it's been tested that about 4 pipe diameters, it starts to go from a plug flow pattern back to a long bullet flow pattern at that point in time. So the only thing about the C note here, folks, is just thermal trapping. This goes back to the days of variable speed injection mixing, when we were trying not to have any migration of the hotter water. If we keep the hotter water up higher physically than whatever, this is not injection, but whatever we're trying to do, we're less likely to get some migration or ghost flow down to these heat emitters, or in this case, a heat exchanger, and overshoot anything on this side of it. So just understand that the C note mostly has to do with thermal trapping. Okay, so the A's and the B's pretty much set forward here. Let's just touch.
Rick, can I interrupt you real quick? I have a question.
Sure.
From Jay King. On some ModCon single boilers, I see flow checks on some and not on others. I'm talking about the supply out of the boiler before it tees into the main loop. Does it make a difference? Flow checks on the boiler supply going into the main loop. I believe that's what Jay is referring to.
Okay, well, I've not seen a flow check provided by the manufacturer unless it's a flow check that's part of the circulator that's supplied by the manufacturer. And when we're doing primary, secondary, and we've got good hydraulic separation, you potentially could get by without the check valve. Here's my personal experience: is the check valve, as long as I only have one of them in there, not 2 of them in series or anything, have never done me any wrong. So integral flow checks, IFCs, have not been a problem in my experience.
All right. Yeah, we got a couple of confirmations on that. Wheel says every pump should have a check. And any chance the flow check is required for an indirect heater?
Right. When we want the 2 circulators not to mess with each other when piped in parallel, like we were showing earlier, absolutely, we don't want a backflow across when one pump's running at another one. So by all means, check valves. Like I said, my take on it is check valves never hurt me, other than if you get them in too close, not an IFC, but if you get out there with some of the spring-loaded ones, and definitely some of the swing checks can tend to make some noise if they're not far enough away from the discharge side of that circulator. Same thing applies. We want a nice long distance downstream. If you put an external swing check or anything, they tend to make noise.
And Dan Cook says, while McLean supplies a check valve on our Easy Up manifold kit. So there you go.
Oh, okay. And that's part of the pump, or is it on the return side of opposite the circulator? And that's I see where he's going. Thanks, Dan.
And while this is all going on, we notice Dave is on Tinder. Have you noticed that? He's on his phone. He's on Tinder. He's swiping left. I don't know what's going on.
I don't know. I can't see anything now because I just got a single screen. All I can see is my PowerPoint presentation. So. Shall we touch on pipe sizing maximums? This is real quick, folks. This is review for all of you, I would assume. Okay, we use rules of maximums with 4 feet ahead per 100 foot. That's what this column is. This is a maximum based on 4 feet per second. Okay, 2 different maximums that are out there. And again, this is specifically for type L copper. So each type and size of pipe okay, will have different requirements. So I use this in my teaching when it's just for L copper. It'll give you a little safety factor for M copper, but if you're doing something different, then use those, whatever that manufacturer gives you, okay? So 4 feet ahead per 100 foot is a maximum, and 4 feet per second is a maximum. Two different maximums out there. All I'm saying by this quick little statement is use the column that best suits your needs, okay? Which one serves you the best as far as giving you the most flow and still staying within industry standards? We look at this typical residential range using 4 feet per second, and that gets us up to about 1.5 inch pipe. Notice this column gives you higher flow than this column. But as soon as we get to 2 inch, it flip-flops. Notice that 2 inch, now we've got 44 instead of 39, 80 instead of 60, etc. So use whichever column suits your needs the best. Both of them are considered within industry standards. So just a heads up on that as far as maximums are concerned. This little chart I put together, I've been using this for well over a decade now, where we're just talking about delta T's based on maximums. Notice here I've got 2 feet per second, and here I have 4 feet per second. All this is just at these maximums, what would the outputs be? For instance, if I had a piece of 1 inch type L copper and I ran it up to a maximum of 10 gallons a minute at a 30-degree delta, what would that give me? Just under 150,000 BTUs. So just understand how to read. This is just at a glance of something I use, and just showing you again the power of temperature differential and what it can do for you for a fixed pipe size. Again, we're not going to run, baseboard at a 40-degree delta, but when we're talking about piping boilers and where we're going with this, it could be used for your help. Again, the boiler manufacturer gives you lots of information. Here's one that's just drawn up from scratch to kind of give you a concept and what I'm saying here, right? Don't oversize the boiler circ. Okay, don't oversize the boiler circ. Again, you guys know what this means, right? Some of you will giggle, and some of you will probably Google it. But anyway, this is what we want you to reference. Reference the manufacturer and what they're telling you. Let's talk about what happens when we oversize the pump. And I want you to focus right here at these two T's, right? I've drawn them up, just simple see-through affair, but let me go back. This is what I'm talking about right here, this area. So ideal flow pattern is always to get the coolest fluid to enter the boiler, right? Okay, and as John was just showing you on that other example, some of it bypasses. It's okay to let some of this colder water bypass and go out. I just want to make sure that I'm getting the coolest water. This is what we would see typically when we have differing GPMs on the boiler side and on the secondary or the main side, however you want to call it. So again, this is a good thing, right? There's nothing wrong with this. It's fairly typical for primary, secondary. Another way, and people have looked at this is an acceptable flow pattern, right? I'm still going to get the coolest here, but what's not happening here? And I want you to think about this, and it might be time to throw out a question, right? I still get a left-handed thumbs up, not a right-handed thumbs up, but a left-handed. And I want you to think about this. In order for this to happen in the way that it's depicted, what would have to absolutely be the same? And I'll throw that out there as a quick question. You guys that can see the John and Dave, let me know what they're giving us back.
Well, we got one. Wheels. We've got Jimmy DePalma's got it. We've got Matthew Burnham's got it. The boiler flow and the system flow are equal.
Excellent, excellent. Now
and
tell me how.
And the pumps are equal.
Yeah, no, the pumps could be the same pumps, but how likely is it, folks, for you to get identically the same flow on the primary as you are in the secondary? Let me just put it this way. It's really, really unlikely, and it's not very practical for that to happen, right? It's just not, okay? If that was the case, you know, you would have balancing valves in there and all that stuff, because the actual pressure drop on the system is going to be widely different than the pressure drop through the boiler and the closely spaced tees and all that good stuff. So understand where we're going with that. You can almost throw this out, right? Here's what I want you to really get out of this. What happens when we oversize the boiler circulator? Well, what I'm doing is there's more flow here than needed, right? So there's really no place for it to go than backwards across the flow pattern and back up, blending with the return and actually warming it up. We're actually warming the water going back to the boiler, and that's usually not a good thing. Now, you folks will understand that on occasion, under light outdoor conditions, we call them bench days or shoulder days and that sort of thing, when the boiler can't go any lower than low, and so on, and the pump can't go any lower than low, etc. If you were controlling the speed, you're going to get a little bit of this. The good thing that we got going for us at those times is that those are shoulder conditions when you don't need really hot water, and possibly even the return temperature is in lower than 130, and even after it's mixed is still lower than 130, and I'm still condensing. Okay, so see where I'm going with that. With a fixed speed circulator at lower loads conditions, you're going to see this a little bit. It's not absolutely the end of the world, but just understand what we're trying to do from a concept standpoint. Okay, again, this is thumbs down on that one. Let's look at some of what the manufacturers actually tell you. So what is the range of delta T that manufacturer will allow? And they'll show you in writing. And if you need clarifications, get with that boiler manufacturer's rep, and they will talk to you about what your flexibilities are. But again, they put this in writing for a reason. This is your get out of jail free card. Let's look at this 155 model. This is from HTP, and in this case, they're giving us some delta differences. Here's 20-degree delta across the heat exchanger. There's a 25 across the heat exchanger, and there's a 30. As you can see, they're giving us 3 different delta T's, and the corresponding differences in gallons per minute I'm pointing out right here. Notice, as we widen the delta, the GPM gets lower. And I'm telling you, lower GPMs on primary, secondary piped fixed speed circulators are a good thing. I'm leaning you that direction. Let's take a look at something. This is a little, if I start putting this all together, it actually starts blending. So I'm going to blow that up a little bit. John, I knew you wanted me to do that, so that's why I did it for you. Ha, chuckle, chuckle. Anyway, so what I'm going to put in here is just some operating points based on those 3 different delta T's that we just looked at, right? So in this case, let's look how they lay out. There's the 20, here's the 25, and here's the 30. Okay, now I want you to really focus on this. Look at what we're in and around as far as pressure drop. Would you get too excited about that? Okay, just recognize that this is contingent on the style of heat exchanger that's being used. And for the most part, right, most manufacturers are offering some sort of heat exchanger that has very low pressure drop. You can tell I'm being careful there, okay? So let's look and see what Lochinvar's got going. Here's their 155, okay? They're giving you a choice of a 20, a 25, a 35, right? See how that's going? All right, so just understand there's your corresponding GPM differences, right? As we could see here. Now notice they also put in some additional information. They have a maximum flow. I think most of the manufacturers, if you ask them for it or somewhere in their documentation, will tell you if there is a maximum. They'll show you what that is. And they also have a minimum, a minimum flow under high fire condition or low fire condition. So look for that information from your boiler manufacturer, because all you're making sure is ultimately that your pump is well within the parameters that the manufacturer said it could be. Here's that same layout for you in that particular pressure drop chart from the manufacturer. In this case, it's Lochinvar, right? So again, there's the 20-degree. There's the 25 and there's the 35. Now notice again, we're not talking at any of these, we're not talking a lot of pressure drop, okay? So just understand that as well. Here's one from NTI, okay? I'm going alphabetical, folks. Here's their 155 or 154, okay? So we've got a 20, a 25, and a 35 that they're showing. Okay, same story, right? I'm just going to go a little bit faster, but I think you get the point. Look how low these pressure drops are, and look how potentially low the GPM requirements are. Okay, those are the two things we're bringing up here when we're talking about mod cons with piped in primary, secondary configuration. Okay, here's one from Weil McLean. And that there's their 155. Again, I'm trying to stay consistent with the boiler sizing just for an even shot across the bow there. 20, 30, and 40 that they're saying here, right? So let's look at their graph as well. Same story, right? Kind of, if you're going to run this many GPM through the heat exchanger, here's what you can anticipate based on that. Now, flow through heat exchanger and near boiler piping. Now, Dan is on the line, and we can do this off. You can answer me later, but I think they might have some additional numbers in there, not just the pressure drop of the heat exchanger. So you clarify that with your manufacturer as well, okay? If what that number means, because we don't want you double dipping and adding for your incidental pipe valves and fittings on the primary piping, the injection piping, right? So anyway, so there's a 20, a 30, and a 40, just showing you it's all the same story for the most part. Relatively speaking, folks, it's not a lot of pressure drop, okay?
Nor is it like it doesn't seem like you'd need to go to contractor no callback mode on that 3-speed.
Never, almost never. So in my experience, the boiler manufacturer, when they supply the pump, because they have no idea what you're going to do with it, tends to shoot for the moon. So other way of interpreting that, the typical boiler manufacturer circulators are oversized, generally speaking. However, many of them have speed dials on them, and it's you're best off to actually turn them down, as I'm trying to convince you with this little segment here, right? So if you're going to size a pump on your own, okay, this again, if you can't get the information from the manufacturer, and like we've already shown you, almost every manufacturer gives you plenty of good information, right? So we take the input of the boiler, we deduct for the efficiency based on the application. We derate for altitude, caloric value of natural gas from their utility. The utility companies can give you the caloric value of the gas, and you can use that in lieu of altitude derates. Most of the time, the boiler manufacturers, when they give you, hey, deduct by a certain percentage based on a certain altitude, those are kind of shooting from the hip. Again, I'm not telling you to do anything above and beyond that. I'm just saying that it's based on, at altitude, the caloric value being less than 1,000 BTUs cubic foot. So just understand what that means. You still have to derate when you're doing your pump sizing. The pumps, the boilers are not 100% efficient, okay? Now they're getting close. Many of them, depending on temperatures, right? But anyway, we take the input of the boiler minus for efficiency, minus for altitude. That's going to give us what we need at maximum output, okay? Let's do a quick example. We have 155, and we've got it kicking right along there at an AFUE of 95 or 96. In this case, we use 95. That gives us 147,250, and I'm going to divide that by a delta T of 30 and a constant of 490. You guys want to use 500, use 500. It's close enough, right? Here's the number. I'm taking this divided by this, and it tells me I need 10 gallons a minute, okay? Now, let's look at that same scenario with a less efficiency. Now, what if I'm doing a whole lot of higher temperature, a whole lot of domestic water production, and I know that boiler seldom is going to run at 95, right? So you use the number that's right for your particular application, but be sure to derate. So now we're down to 133. We'd use the same numbers, a 30-degree delta. There's our constant. That gives us 9 gallons a minute. Nice round seminar land numbers, okay? Now, what if many of the folks on this call are from the mountain area where I'm at, right? Denver likes to derate about 16% based on the caloric value of their gas per cubic foot. So guess what? This 155 is no longer 155. It's 130 on the job site. Do you see what we're saying there? It's not a 155. Don't size the pump on 155. Size it on what it is. It becomes a 130. We still have a kick based on efficiency, so we deduct again. Okay, see what we're doing? 155, 130, 123. This is getting us more into the reality of what the pump sizing needs to be, right? So we do the same calculation. We take 123,690, 30-degree delta, constant of 490, and we get 8.4 gallons a minute. Look at this, folks, 8 gallons a minute for 155, okay? Same thing applies here at a less efficient application at 0.86. Okay, I'm getting it down to around 7 gallons a minute. You see what we're talking about there. Just remember to size the pump appropriately. No more shooting from the hip. You know, you've been given all the information. The manufacturers are giving you this information as well. Usually what they're not doing is doing these altitude deducts. That's why I just wanted to show you real quick. Again, refer to the manufacturer, make sure you're good with those numbers, and I think you'll see I'm right. So estimating the pressure drop of the piping circuit of the boiler, right? Just that short little, relatively speaking, a distance between the boiler and that main header that you're tying into. In this case, we're just going to go with a nice round number for seminar effect. And we're going to say the boiler's pressure drop. You guys saw it all over the place, but generally speaking, on those fire tube style heat exchangers, you're looking at 2 feet on that particular size of heat exchanger, right? Then you add for your near boiler piping, valves and fittings, incidentals, anything that's in the circuit of the boiler and that main header. It can be as low as a foot, kind of like we used to use on cast iron boilers, up to maybe 3 foot, depending on the components, the number of fittings, and what the distance is. But it's usually no more than that, okay? So remember, don't add a bunch of fudge factor in there, okay? So just keep in mind, right now I need a pump at 10 GPM at 5 foot ahead. Lo and behold, the 0018E, my best foot forward currently on this small pump. Now, again, this pump is operating by itself, standalone. You're going to apply line voltage to it. It's going to come on and run. But the cool thing about the 0018E, or several of our pumps out there, is we actually have on the dial a min-max setting that we can turn this thing down anywhere between 4 watts and 44 watts. And that's a beauty in this situation. Anywhere between the shaded areas where I can run that circulator. In our case, we want 10 gallons a minute, right? And we're at 5 foot ahead. So I'll bring that over, tie that together. There's my operating point on a 0018E. That's how easy it is. If you're scared about that number, you still got room to move it up, okay? But I think you'll find you'll actually be moving it down. All the boilers, to the best of my knowledge on the market nowadays, pretty much give you what the delta T is across the heat exchanger. Guess what, folks? Try to create or be in a design condition, and that's really where you get to set the pump speed. Okay, so again, that's another story about doing commissioning and you know, testing your combustion and all that stuff. But for now, let's talk about the 0015E3, a little less expensive pump, but it still would do a good job. Remember what this has, a 5 foot of constant head, it's got 10 foot of constant head, and it's got high speed. The proverbial contractor no callback mode. So in this case, we're going to turn it down. Okay, that's the good thing. We're going to run down here at 5 foot ahead setting, right? And we're going to have a good operating point at the same place you saw in the 0018. It's just that now it's just going to find its little hydraulic equilibrium point, and it's going to rock right there. There's really nothing going to change the speed of that, okay? Because we don't have automatic zone valves closing, opening, that sort of thing. So that's where it's going to run. So good enough, right? So keep this in mind, and we always cover this to make you understand that whole tightening, the you know, what do you call it, John? The amazing shrinking delta T, right? So you know, there's usually when we talk about shrinkage, it's a negative connotation. So you know, be careful there. Okay. So a boiler input, right? What if I cut this in half? We were at 10 gallons a minute. At an output of this boiler here, right? So what if the boiler circulator stays at 10 GPM? What am I going to witness here? Okay, well, we've showed you this math before. We take the new load at a 50% reduction, right? And we do the calculation based on 10 GPM. Okay, we're saying the GPM is fixed. Well, folks, that tells me my delta is going to go from 30 down to 15 at a half load condition. And remember, part load conditions, okay, John, give it to me. how often, how much of the actual heating season are we less than 100%?
Almost all of it. Yeah, almost all of it.
All of it.
Yeah.
So understand what we're saying here. This is my next bullet. This is why I'm emphasizing the fact that when you do this initial calculation for a fixed speed circulator, folks, how low can you go? Okay, when I say low as possible, don't exceed what the manufacturer tells you if you want them to back you up. But as you can see, and I've shown you, the manufacturer has a pretty good allowance for stretching that delta T out.
Very good. Got a couple
So,
quick,
yeah,
one
go
quick
ahead.
question here, Rick. And it's came up a couple times regarding the 490. Glycol obviously changes this, right? If
Oh,
the
absolutely.
the more glycol you put in, and you're presuming no glycol in here, right?
No
Usually,
glycol, but it's just hot water. 140 degrees. 490 is about good for hotter water.
right,
500 works for room temperature water. Okay,
right.
so
60-degree water, and
yeah,
the warmer it gets, the lower that number goes.
the lower that number goes. Yep. And
Right.
as you said, when we add glycol, that number even goes lower. Okay.
Which means
So
the flow rate goes higher. Higher. There we go.
yeah,
Flow rate goes.
you'll slightly up the flow rate to compensate for that reduction in density. Yes.
Very good.
Yep.
Right. Excellent.
So just to understand what we're trying to do, I'm gonna start off a couple things here in the buffer tank world, and I'm gonna hand it back to Johnny. Okay.
All righty.
Buffer tanks come in lots of different shapes and sizes, folks. Okay, lots of different models out there. We got the little short, fat ones. We got the tall, skinny ones, etc. If you're looking for stratification, the taller the better, but sometimes you don't need it. So just heads up on what that does. Again, what do they do for us? They add mass to the system. They keep us from short cycling that piece of equipment, but leads it to an early grave, as you've heard John say so many times. And they do a good job of hydraulic separation, okay? And we can even do a fairly good job of air and dirt separation as well. On some of those drawings, I still had a 4900 on there because no one gets anywhere close to Taco's 4900 with their pawl ring technology. And that's a whole nother thing we could talk about some other time if we want to do a segment on air separation, okay? In this piping, we're just saying what we want to do is focus on where we control the boiler, okay? We were talking about this earlier, and I had to reach out to some of my amigos out there, just reminding me, because I've been with Taco 5 years. I want to make sure that nobody's doing anything different other than what's being done. Just as a general rule, when the boiler manufacturer gives you the ability to put a system sensor on, then we would take that system sensor and plug it in to the buffer tank and let the boiler operate off of that average temperature in that tank. Then over here, we'll make and break power to the circulators or the zone valves, etc. We'll do all that for you. And then we'll just be pulling off the buffer tank, okay? As long as the boiler manufacturer does not fire the boiler when the TTs are pulled in, and many of them do not, right? They look and see what the temperature is before they fire the boiler, which is a good model. Okay, so understand that I don't bring the flame on if I have enough energy in the system to not have to. So general statement there. Okay.
Or if you can satisfy the call for heat without firing the boiler, it doesn't get a whole heck of a lot better than that, does it?
Exactly. Again, what we're doing is we're depleting the energy out of the tank, right? And then when we finally do pull the boiler on, then it gets a nice long run time. Okay, so we just keep saying that long run times are a good thing for overall system efficiency. We don't use the term much anymore, but remember the term steady state efficiency. Okay, we don't get much when we bang the boiler on and off. Okay, no matter what the AFUE is of the piece of equipment. So understand that anyway. So buffer tank piping as well, same thing here. All we're showing you is when we're doing domestic hot water, we want to pull it off parallel, what we call parallel, these two pumps, right? This one goes in and feeds the buffer tank. This one can take priority and just take care of the domestic load independent or stand alone of what this is doing. Okay, so understand that. That's just, we want to show you a couple different pictures there. John's going to get into this even more about the sizing of the tank, which is very important, right? So this is just to let you know, this is our ZVC 406 EXP, right? Again, I'm not going to go into every point of connection here. Just understand we can still do, we bring the main back to the boiler's TT. If you have a domestic call that's separate, like we just talked about, we would bring that back to the separate boiler's domestic hot water call. And again, even if we get a call from a thermostat and we open a zone valve and we turn on the circulator, it does not mean the boiler is going to fire, even if we close this. You'll have to check with your manufacturer to make sure that doesn't happen. So any questions up to this point, John?
There was one on that last drawing. The boiler is drawing from the boiler in that last diagram. I'm not sure.
Okay. Okay, that's good. People love that. That's why a picture's worth 1,000 words, right? The boiler manufacturer will tell you if you can or cannot pump away from, or you must pump into. So this particular manufacturer, when this drawing was done, has no problem whatsoever of pulling away from the heat exchanger. The style of heat exchanger that this boiler had no more worry about that than a cast iron boiler did. So again, always check with your boiler manufacturer. Okay, hopefully that answered that question.
Very good. All righty.
Okay. All right. Well, anything else?
Oh, let's get into some sizing here, and then we can address the questions. I want to go through sizing. Hey, look at that. I need a little shave. There we go.
Yeah,
that's what I wake up to every day.
I love it.
All right. I want to get my screen up here. Let's see. Can you guys see my screen?
We got you.
Yes.
All right. You see my my PowerPoint, because all I do is I see you guys.
I see your PowerPoint.
I don't see my PowerPoint. Oh, there's my PowerPoint. All righty. Let's move this out of the way.
Flounder and me. That's what I see.
There you go. Let's go into how do we size a buffer tank? How do we size a buffer tank? And it's a pretty simple formula, pretty quick formula. So we'll go through it very, very easily. Basically, you start with the minimum boiler firing rate. Whatever the lowest firing rate is with that boiler's turn down ratio, it's the minimum boiler firing rate minus the BTU output of the smallest zone. A minimum boiler firing rate minus the BTU requirement of that smallest zone. So minimum boiler firing rate minus the load of the smallest zone. That gives you something called the BTU surplus. The BTU surplus. Step 2. Let's multiply that BTU surplus by a desired minimum runtime. Typically, we use 10 minutes, meaning every time that boiler comes on, we'd like to see it fire for 10 minutes, all right? So BTU surplus times desired minimum runtime, 10 minutes, that will equal what we call the cycle factor. And then finally, to size the tank, you'll divide the cycle factor by the delivery side delta T, the system side delta T times 500 or 490 in this case, or whatever, you know, whatever you have for a fluid mix will determine that number. So cycle factor divided by the delivery side delta T times X, in this case, we're going to call it 500. That will give you the tank capacity in gallons, all right? So minimum boiler firing rate minus the load of the smallest zone gives you the BTU surplus. BTU surplus times the desired minimum runtime gives you cycle factor. Cycle factor divided by delta T times 500, delivery delta T times 500 gives you the tank capacity in gallons. This is really important when you have like radiant systems or something where you have micro zones, where you have a lot of little zones that are smaller than the lowest firing rate of the boiler. That's when a buffer tank really sings and dances. And when you combine it with that wiring and firing strategy that Rick just mentioned, you've got what very well may be the most efficient potentially the most efficient hydronic system possible, particularly if you use a delta T pump on the delivery side. So let's do one here really quick. Let's say I've got that 150,000 BTU ModCon, and it's got a 10-to-1 turn down ratio. So it's a $1.50 BTU output ModCon with a 10-to-1 turn down ratio. And the smallest zone is 5,000 BTUs. Again, it's a radiant system. It's a small, aggressively zoned system. So 150,000 BTUs with a 10-to-1 turn down ratio. What is the lowest firing rate? Well, the lowest firing rate obviously be about 15,000 BTUs. So 15,000 BTUs minus 5,000, the low to the smallest zone, gives me a BTU surplus of 10,000. Next, I want to multiply that BTU surplus times my desired minimum runtime of 10 minutes. And that's going to give me a cycle factor of 100,000. To size the tank, I'm going to divide the cycle factor by the delivery side delta T times 500. Now, let's say this is a full radiant system, and my delivery side delta T is 10 degrees, which you would have for, just common for residential radiant. So my delivery side delta T of 10 degrees times 500, well, that's 5,000. 100,000 divided by 5,000, that means I'm going to need a 20-gallon tank, a 20-gallon tank.
Minimum.
Yeah, minimum of 20-gallon tank. Well, I can't find a 20-gallon tank. I can only find a 15-gallon tank. I can't do this. There's no crying in hydronics. No crying in baseball. No crying in hydronics. Right? So you put in a 15-gallon tank. What's the worst freaking thing that's going to happen here? Oh, you're going to have about an 8-minute minimum runtime instead of a 10-minute minimum runtime. Call a cop, okay? It's not that bad. It's better than 15 seconds, okay?
Boiler cop.
Yeah, call a boiler cop. Oh, I can only find a 30-gallon tank. I can't find a 20-gallon tank. Wah. Call the ambulance people. You're going to have a longer than 10-minute run time. All right. Oh, the horror. How will we cope? It's going to be better. All right.
Yeah.
We were talking about this earlier today. Buffer tanks are like expansion tanks. Within reason, you can't really oversize them, right? You can't really oversize them. If you undersize them too much, you start to get into, it's not a buffer tank anymore. It's a hydraulic separator. All right. So you're not getting the maximum benefit that you can out of a buffer tank. And buffer tanks, when the smaller zones are smaller than the lowest firing rate, buffer tank is, to me, it's kind of mandatory every single time. If your smallest zones aren't that small and they're kind of equal to or maybe a little bit greater than the minimum firing rate, well, then a hydraulic separator will do you just fine. If it's just one big old honking zone, maybe it's a boiler replacement for one big old honking zone system, well, then the closely spaced T's moose-antler piping will do you just fine. All right. So that's kind of just a nutshell on how you might want to make that work for you and some guidelines for when to use what. All right. Now, our trivia answer. So as of this moment, no more answers. A lot of people got it, mostly. So we're going to be specific about this.
Yeah.
The trivia answer is the product manager who was actually running the project of building the 007 was a huge James Bond fan. And back in those days, the project manager who was working on the development of any project could name the project whatever the heck he wanted. If he was a big fan of My Three Sons, he could call it Chip, Ernie, or Robbie if he wanted to. But this guy was a fan of James Bond, so he called it the 007. And as very commonly happens in a long-term project, everybody refers to it as Project 007, Project 007. Well, what are we going to call this thing when we finally come out with it? And all too often, everybody's kind of tired of the project and wants to get it the hell done. So let's call it the 007 and move on. But that was the birth of the 00 series of circulators, the iconic 007 and the 00 series of circulators, which has become the Takeo brand. So that's kind of the story behind that, and I hope you find that it's nice to know. It's nice to know. All righty. Now, what's up next week? Well, next week we're going to talk about mixing valves. We're going to talk about multi-temperature, multi-load systems, and we're going to talk about understanding indirects. And I think next week we're going to give the con to Mr. Holdorf and let him carry the ball for a little bit. All right, because again, you guys seem to like me shutting up. I don't know if I should be upset about that or not. But as a group, you seem to like the fact that I was shutting up here for a while. So all right, I'm all about giving the people what they want. All right. So if I got to shut up again next week, well, I'll shut up again next week, and we'll have Dave run that show. So That's kind of it. Again, I want to make sure everybody understands. If you guys are into these sticker things, Dave, how's the sticker supply going over there?
Oh, I got a ton still here. I'm doing good.
Alrighty.
I'm doing good. So, yeah,
I
have
still
some
don't
fun.
got mine.
And yours went out in the mail today. Yes, I know. I fat fingered the address there. So, and Zvi, I'm sending yours out today too. So yours are going out too. So
All right.
I sent a whole bunch out today. Yes.
Yeah, contact Dave on Instagram at Takeo Training, and just send him your mail. Direct message him and give him your mailing address, and he'll send you out some stickers.
John,
All righty.
do you have
Very
a
good.
007?
Stickers.
Say again.
Do you have a favorite actor as 007?
Do I have a favorite actor as 007? That's a good question. You know, Connery is the icon. I mean, everybody loves Sean Connery. I like the one with George Lazenby on Her Majesty's Secret Service. I really enjoyed that. I thought he did a great job. I think a big part of it was that in the late 60s, I used to watch the Avengers on TV, and I developed one of my very first feelings was centered on Diana Rigg as Mrs. Peel. And she was Tracy in on Her Majesty's Secret Service. And that's why that's one of my favorites. I love that one. But then again, Goldfinger, unbelievable, great movie. I'd say Connery, Lazenby.
Moore?
No, some of the Roger Moore movies were very campy, but that was the 70s, right? They were very campy. That was the 70s. I liked Pierce Brosnan. I like Daniel Craig. I like Timothy Dalton. I might be weird. I'm one of the few to like Timothy Dalton. And I like Roger Moore too. There's not a bad Bond, man. The only way, if they gave me the role, okay, then I'd be a bad Bond. But those guys they picked were all very good. But my favorite's going to be Connery, then Lazenby, and then probably Brosnan.
Nice.
Yeah. How about you?
I think Connery, he was a classic. He was.
Yeah, I'm with the Connery. I do like Daniel Craig because it brought it to a different level. I thought with him and made it darker. So I do enjoy the Daniel Craig parts. Yeah,
I agree.
Yep.
Yeah, I mean, Moore was great. I mean, that was the Saint. That was the character he played, was the Saint from his old TV show, and it was campy. Although For Your Eyes Only was maybe one of my favorite ones with him. That was a terrific movie. I liked that one a lot. That was maybe the best for my money. That and The Spy Who Loved Me were the two best Roger Moore ones. And he was a perfect Bond. He just was like 90 when he did the last one.
Oh, hey.
Alrighty.
We got to do last week's trivia.
Oh yeah, we got to pick last week's winner. Sure.
That's right. That's right. Yeah. So last week, I'm sorry, hang on. Let me get this queued up here.
Do you have your wheel?
I have the wheel. Yes, I do.
Well, let me make you the presenter.
Yes. Oh, you're going to make me the presenter then.
And
okay.
It's Otter. It's not Otto. It's Otter. Otto was Kevin Kline in A Fish Called Wanda.
I didn't finish typing. Sorry.
Oh, Dave. Hey, guys, thank you. Richard, thank you very much.
All right. Let's see here. What screen do you see right now?
I see your PC documents. Your whole Take After Dark folder. There you go.
All right. Let me change that. Okay.
Chuck McDonald. I'm with you 100% on that. Yes, I like Diana Rigg. Batgirl was the other one that did it for me. Batgirl and I'm gonna say even Catwoman. Julie Newmar Catwoman on Batman, along with Yvonne Craig on Batgirl. That just set me on a path, and then we'll leave it at
that. Show screen. Here we go.
There you go.
All right. Let me just get that out of my way. I can't see it there. All right. So last week we had the trivia question was during World War II, Takeo joined other manufacturers to produce critical components for the military. And what two products did Takeo manufacture for the U.S. war effort? And the answer was gun mounts and heat exchangers. We had quite a few answers. So you see those handful of guys that did answer it last week. and let me click on who's going to win. So tap to spin. Let's run that around. And as long as it doesn't land on the Takeaway After Dark logo, we're good. All right. And it looks like, yes, Chris has won. Excellent.
Ding, 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 ding. Way to go, Chris.
Chris, I will contact you for shirt size so I can make sure you get the right size hoodie for yourself. And I'll send you an email or find you on Instagram and we'll get that sent out to you. So excellent. Good job, brother.
I think next week it's going to be the Takeo home game. We need to come up with a Takeo board game. I think that would be kind of cool. That would be kind of cool.
All right. We'll have to look into that. Definitely.
This is going downhill in a hurry. We had a fish called Wanda. It was great. Why Eartha Kitt? I liked Eartha Kitt, but there was something about Julie Newmar. You know, Lee Merriweather was terrific too as Catwoman, but there's something about Julie Newmar and the way she purred just grabbed a 7-year-old John and took control of his mind. Let's just put it like that. And then, you know, Marianne and Ginger, yes, okay, from Gilligan's Island. I'm a Marianne guy. I'm not ashamed of it. You know, not that there's a wrong choice here, but yes, there we go. I'm good there. Okay. Did you just say 7-year-old John? When I was 7 years old, yes, back in 1967, I was 7 years old. Long time ago in a galaxy far, far away. I can still remember when the music used to make me smile. Oh wait, that's putting two different. That's American Pie and Star Wars. They don't really go together, do they? I don't know. All righty. All right, guys. Now this is just the part of the session where, you know, we'll stay on and talk and yak with you guys about whatever for as long as you want. Whatever questions you have about the stuff we talked about today, about stuff that just is, you know, questions that bother you so about the world in general, about hydronic heating, about Takeo products. This is just pull up the toolbox and let's have ourselves a chat. This is you know, we peaked at middle sessions. We were going on for like 2.5 hours. We'll stay on as long as you guys want, as long as you have questions. The official presentation is over, and you know, we're down to 168 of you out there. But whatever questions you might have or thoughts, ideas, you know, what kind of topics would you like to see us cover in the future? Because I think, you know, we'll talk with John about this. If we want to keep going through the summer, we sure as heck can. There's nothing to stop us. But we can continue to discuss whatever it is you want. I know Mike wants to see the buffer tank calcs. Let me. Am I the presenter here? Yeah, I'm going to put a presenter. Show my screen. We'll see if I can get that up there for you. All right, there it is, sort of, kinda. Now let me, I'm gonna move backwards here. Hold on a second. All right, we're gonna go back here, back here, back here. There we go. Is that the one you're looking for? Mike, let's see if that one's good for you. Got it. All right, excellent, excellent. Buffer tanks are working better with the loads between the boiler and the tank. Tank sees much less flow and stays stratified better, says Richard McGrath. Yeah, I tell you what, I mean, I just like the idea of a delta T pump on the or pumps on the system side, keeping that delta T steady, going through the tank. All right, going through the tank, and then and then the boiler only firing when it needs to recharge the tank, so to speak. So like we were saying earlier, when you can satisfy a call for heat without ever firing the boiler, folks, it doesn't get any better than that. That's as efficient as a system can get, right? And if you maintain that temperature in the tank and the boiler only fires when it needs to, we've got a system that's that's singing and dancing with all the music in the world, and it's terrific. This is a great way to run a heating system. So you got delta T for the you know, to keep that temperature nice and wide on the system side, size the pump correctly on the boiler side with that added mass. Oddly enough, this is what we're doing. We're taking a low mass boiler, which is how, you know, modcons get their efficiency, and we're turning it into a high mass boiler. Isn't that crazy? Kind of like the way boilers used to be. I don't know. Just I find that ironic, but that's kind of the way it is.
Hey, John, can I throw something out there? you know, we get in correspondence back and forth and little notes and stuff. But my buddy Mike Miller up in Canada reminded me that uh, that the multi-purpose tank is a buffer tank and lots of other things as well. And that was the first picture I showed when I was talking about buffer tanks coming in all shapes and sizes. So, and that's for not everybody on here is strictly residential. You folks that do commercial work, keep in mind that Taco makes the best multi-purpose tank on the market in the big ASME product. That's you know, heads up. Okay, take a look at the things you don't know that Taco does. There's a lot of it.
There is a lot of it. Here's one from Doug Specht. I hope I pronounced your name right, Doug. Any thoughts on the Viessmann CU3A high mass, low head ModCon boiler instead of a wall hung boiler and a buffer tank? Again, if the high mass boiler and low head loss, if it's got some water content, that can certainly help. I mean, I'm not familiar with that boiler per se. Or do either of you guys have any familiarity with that product?
I've seen it, and what they're doing a little bit different is with all that mass, they don't need the turn down. That you know, like we got residential turn down of 10 to 1, in some cases 15 to 1. Again, if I have a big boiler with a whole lot of water in it, I don't need to turn down as far, because basically you have a buffer tank built into the same cabinet. So think of it that way. So again, I get decent on times because I have so much volume to heat up. I got a big sponge, in other words.
Very good. Very good. Here's from Dan Cook. You mentioned the straight piping into the closely spaced tees. Mention that the individual components of the system need some straight piping into and out of these components. What component is most affected by short pieces of pipes or 90s in the system?
One thing, we're a circulator manufacturer, and we actually want nice long distances of pipe before you enter the suction side of a circulator. However, it still works, but if you want to do it right, you want nice long straight pipe before the suction side of a pump. So
very good. Excellent. Excellent.
That's the one that first came to my mind, but it's open for discussion. So
here's one from Jordan. Best resource for sizing an external flat plate heat exchanger running off a storage type water heater. Thoughts on it being able to keep up? There's a lot there that we don't know in terms of what information. When you want to size it, an external flat plate, I mean, find your flat plate heat exchanger supplier of choice, and then see what you have for water temperature, how well it transfers heat from one side to the other based upon flow rate.
Right.
You know,
you look at your water temperature that you're going to get out of your heat source. What water temperature do you need? What the delta T is, or they call close approach, you know, from one side to the other. But yeah, check with the manufacturer. They usually have a little app on their website you can easily size that from. Yeah.
And Jordan, we also have a terrific little product called the X Pump Block, which is 2 pumps and 1 flat plate heat exchanger in one nice little package. A lot of folks will use it off of a water heater, and they'll run the domestic water through one side, and maybe they have a little bit of radiant floor heating or something on the other, and it keeps the two systems separate. But it's kind of like what you're talking about there, Jordan. But take a look at our website and look for the X Pump Block. It's got the controls, it's got everything. You just mount it on the wall, 2 pipes this way, 2 pipes this way, plug it in, program it, and bada bing, you're good to go. So that's that. But again, you've got to know what the math is to make it work, and if it will do enough for you. Okay, very good, very good. What other? Boy, a lot of stuff coming in now. We asked for it, and here she comes. Excellent, excellent. Yeah, can we get that, Jordan? Sent. Yeah, we'll be able to get your email address. Yeah, Dave's on top of it. Dave, good man. Gotta love. You're gonna get your takeaway sheet coming up. After my HVAC career, I would love to learn about speccing out a system for new construction. Any recommendations for training to get more knowledge and potentially certified? There's not a lot of certification in our industry, is there? I mean, you got Nora, you've got Nate,
but more for the installers and stuff. Yeah, not for designers.
Yeah, not so much for designers. You know,
keep in mind the Canadians all have to be certified to actually design Radiant Systems, and it's typically the host sailor that takes that responsibility. So they have a stamp of certification to design and then sell hydronic radiant floor systems. So Canada does a really good job of that, making sure. And again, certification for specifically hydronic classes. So just heads up for our Canadian brethren as well.
Our Canadian brethren. There you go.
Yes.
Mike Byers
ASS,
says,
yeah. Go ahead. Sorry.
what?
I was to further that with Rick. So RPA and ASSE are trying to put together some sort of codes across the United States also. And ASSE 19210 is also a certification process that we are trying to get moving along here in the states themselves. So those classes are available. So you could take a look at the RPA's website or ASSE's website also. So Rich, thank you for reminding me of that. So I think you went through the training, and I went through the training too, and was certified. And they have two different training certification classes, one for designers and one for installers also.
Very good. Very good.
Mike Miller called that out. It's Canadian Hydronics Council, CHC.
CHC. Very good. Very good. Mike Byers has a Mike Byers, not Mike Myers. That was Dr. Evil and other characters played by Dave Holdorf.
Yeah.
On the slide on the buffer tank just shown, why is the Delta T 10? Well, that was for radiant systems. Residential radiant systems are commonly designed to a Delta T of 10 for consistent floor surface temperatures. Not all the time, but most of the time, particularly if you're going in between the floor joists or in like a gypsum concrete pour or in the slab in a residential application. We'll have the water go out, let's say at 120 and come back at 110. The purpose for that is for comfort. It's for more consistent floor surface temperatures. So that's why we used 10 in that example, was simply because we considered it, we proposed it to be a radiant system. If it wasn't a radiant system, we could have used 20, and then instead of a 20-gallon tank, we would have had a 10-gallon tank. How about that, And then you'd have to find a 10-gallon tank, and we'd go through the crying all over again.
10-gallon hat.
10-gallon hat, 10-gallon tank, man. That's right. High mass boilers take more energy to get up to steady state, but once they're there, they act like a buffer tank. However, the best efficiency, low mass, and properly sized BT is a little bit better. I'd say you're right. And if we can put the two of them together, put a real efficient engine with a real efficient delivery system and that little, storage in the middle, now we really got something, man. We've got something pretty cool. All right, very good. The plumbing apprenticeship in Canada is expanding the hydronics in the new curriculum. That's a pretty cool idea. I think that'll work out really nicely. I mean, here in the U.S. for hydronics, when I worked with the tools way back a long time ago, you know what you needed to be a hydronics guy?
A wrench.
Tools. You needed tools.
Yeah.
You needed tools and a van to get to the job. That's what you needed, right? And there was no licensing, there was no training, there was no nothing. It was just get out there. The training program was go get them, and I still remember walking through jobs with my brother when he was teaching me about this stuff. He'd have the blueprint, he'd have the printout from the wholesaler on the design of the hydronic system, and it would say, and this was in Massachusetts, it was this heating system is designed to maintain 70 degrees indoors at -10 outdoors. I remember thinking it never gets -10 out here. This is why is this designed to -10? I asked, and he goes, "Shut up." I said, "Oh, that's why. Okay." There had to be a reason. And we'd walk through it had a room by room printout of how many feet of baseboard was supposed to go in each room, and he'd say, "Okay, the printout here says we need 7 feet of baseboard in this room. We're going to put in 9. Well, why are we putting in 9 when it only says 7? Shut up." All right. That was the training program, basically, because we don't want a phone call. We want to make sure they have enough heat. We don't want to shortchange. We don't want the phone call in the middle of the night. Shut up. And that was training. All right. That was training. At that point, if you wanted to learn more, you were on your own. All right, you had to go to classes. You had to go to the IBR school. You had to go. I remember seeing Dan Holohan in 1991, and my life changed. Okay, because I said, "My God, this guy can make a living getting in front of people and talking. Maybe there's hope for me yet." So that's kind of where I was at. But it was that's what we had. I don't know, Rick. How was it for you?
I was reading something. I got distracted.
sorry.
As far as working with the tools or what?
Yeah, we're training. How did you learn? How did you learn this stuff?
Out on job sites as a wholesaler, regional manager, people having problems, going out there, finding out what the problems were, leaning on me for design assistance. And then I just tried to explain it to people the way that my mind would receive it. And if I saw them doing this and they did good jobs, then I said, okay, I must have said the right thing. But anyway, that's how I got into it. It was through the wholesale business, and prior to that, of course, I was working with the tools as well.
There you go.
I never finished never got my journeyman, but I did like 3.5 years of plumbing, installation, heating mostly. So
Now, Dave is unique amongst us because he actually has an engineering degree.
yeah.
Don't tell anybody that, because now they won't listen to me.
Well, no, you look at Dave and you take a good look at Dave. It's real easy to underestimate Dave. I got to tell you.
He's a tough boss. We should turn him into HR. You think, Dave?
He didn't touch me. He didn't touch me above the elbow.
There you go.
Okay. All right.
And not being smacked in this is a good one. Not being smacked in the teeth. Where is that, Richard? I'm sorry. It just moved on me. You look like you had a good one there.
Not being smacked in the teeth could be considered a passing grade in my family.
There you go. Good question from Ferris Stanley. Ferris, based on the question you asked here, I would recommend contacting your local TACO commercial rep wherever you happen to be, and they can help you out with sizing something for an 80-ton chiller. Because based on what your info, none of us could give you any kind of a clue of what to use for an 80-ton chiller. So I'm not sure if you'd let us know, Ferris, where you're from, and maybe we can give you the name of the right people to talk to. It's if you want to size a pump for an 80-ton chiller cooling with a cooling tower. We got stuff that can do that. It's just it's a little outside of our skill set.
Yeah, if I can't carry it in one hand, I'm not training on it, right?
That's right. If I can't pick it up, I don't train on it. That's just the way it goes. Is there a good way to prove loop layout efficiency? For example, using a reverse spiral method versus serpentine layouts, especially when radiant inflow is more of a luxury supplemental heat alongside of a forced air system? No, not that I know of. I'll give you a straight answer there. Michigan, you want to call Emerson Swan in Livonia, Ferris. Emerson Swan, ask for Mary. She's really sharp, good engineer. She'll be able to help you out and point you in the right direction. So Emerson Swan in Livonia, Michigan. They'll help you out there. Reverse, when we worked at, all four of us, or three of us worked, all four of us, there's only three of us here, right? All three of us worked at Uponor for many, many years. And, we used to talk about serpentine tubing installation versus reverse return or spiral or chase the tail. And what we found is if you have the reverse return, the spiral, the serpentine pattern is if you had a cold outside wall, bam, you bring your hottest water there to the outside wall and you serpentine back and forth in front of that outside wall. And
okay, I found this on the web for is there a good way to prove loop layout efficiency, for example, using
You must have said something that sounded like
that's
Siri.
I got her attention.
Yeah, you did.
Siri,
shut that lady up.
But the serpentine pattern basically use the hottest water out there first, and then it gets cooler as you come in naturally, where the heat load goes down. And that's we're splitting hairs if you want to maximize the efficiency of a tubing layout. I mean, really, it's
more about the comfort level than it was the efficiency of the system. The efficiency was the efficiency. Yeah.
Right.
So
right.
It's more the comfort level that you got out of it. The only time I did a spiral pattern is typically on snowmelt.
Right.
Just so I had a more even surface temperature outside.
Yeah.
So yeah.
Or a room where, an indoor room where you had no interior of a room where you had no outside walls at all. Then the reverse return pattern or the spiral pattern makes sense. But to me, it's a distinction without a difference, or a difference without a distinction. One of the two. Radiant, like most things, can be ridiculously overcomplicated. It's a heating system. We're not flying this thing to the frickin' moon, people. All right, it's a heating system. it's simple is good. You know, I'm not a complicated man, and
Yeah.
I don't, you know, very, you know, subtleties escape me. All right, you know, it's just keep it simple. That, you know, hottest water to the outside, get, you know, and have it come on to the inside. Keep things simple. I think makes a lot of sense.
Yeah.
So
And especially what Jordan's talking about, because he's doing a lot of floor warming applications, it seems like, too.
mhm, yeah,
So in my opinion there, you put it in the easiest way possible. So and you know, just for the pattern to run into the space itself, if you have the freedom of doing a concrete pour or a mud job or something like that. One of the guys here, Eric Miller, was saying, well, if it's you're doing underfloor, your joist is your pattern. Yeah,
yeah,
it doesn't change anything. Your joist is the way it goes in.
right.
So you don't get to change that. So yeah, exactly right.
It's interesting from a youngster. I'm presuming you're a youngster. Dominic, this is saying hi from Norwich Tech Plumbing and Heating. Was told to watch this for an assignment. Oh, good.
Ah,
You,
good.
is this sort of like being on double secret probation, Dominic? You know, were you bad in class and you had to watch us?
That's funny.
Hey, awesome. I'm glad. I hope this was helpful for you, Dominic. Appreciate it and appreciate the comments. You know, make that good for you. Okay, here's was there not an apprenticeship program in the area you worked in, Dean? Asked Gord. Gord, not for heating, no. For plumbing, yes. I was an apprentice and I went to got my journeyman's ticket and all that. That was for plumbing only. Massachusetts code at that time, there was no code for heating installation. You had to have an oil burner's ticket. You had to get it. You had to go to school and pass a test to be an oil burner technician. You were part of the plumbing license was the gas fitter's license. Okay. But as far as hydronic heating installation, no, there was no code. There was no, and as far as I know, there still isn't in Massachusetts. All right. And in many parts of the country, there isn't. You know, what did you need to be a hydronic heating installer or a forced air installer for that matter with tools? You know, that's pretty much it. Okay. And there are other parts of the country still to this day where you don't even need a plumbing license to be a plumber. You just need, you know, tools and a van. And the market is supposed to take care of itself. Very good, very good. So no, I hope that answers your question. That's just the way it was, you know. What's the easiest? Whoa, we jumped up again here. Let's go, let's go, let's go. Boom, 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 boom.
What's the
What is the
easiest?
easiest yet smartest thing you can do when designing a hydronic system? Do a heat loss calculation.
Do the math. Yeah,
Do the math, man. Do the math.
do the
It's
math
the
all day.
easiest thing you can do. Do the math. It's addition, subtraction, multiplication, division, stuff you mastered by 5th grade. You're going to spend more time collecting the information than you are actually doing the calculations. But to me, do the math. Do a heat loss calculation, size the boiler properly, size the pipe properly, figure out the pump, size that properly, install the right amount of heat. You know, go back here to the very first session we did 9 weeks ago or 8 weeks ago and follow that formula. To me, that's the easiest way there is. You know, the guys always looking for the shortcut. Well, how do I do this if I don't want to do that part? Just tell me what to do. No. You got everything's a little bit different, you know. So that's how I would look at it, Mike. Start with doing the math and then go from there. All righty. What else do we have? Air guy trying to be a wethead today. All right, good. I'm glad you could come around, Jeff. That's good. Mr.
No,
Riley. Mr.
he's
Riley.
talking about somebody
Oh,
else.
he's talking about somebody else.
Yeah.
First thing I told him was those 3 007s are mounted before the mixing valves. That's wrong. They need to be after and pull through, not push into. His reply was the homeowner says this system has worked great for 12 years, so I'm not going to change it. Other than saying, okay, goodbye, Cletus, what would you do to convince him?
I would say show him the manual and what the manufacturer says, and show
Right.
him not just one, but show him 3 from different people that all say the same thing, and then hopefully you'll get the point.
I turn around and say, well, you called me. Why am I
Yeah.
here?
Yeah, you called me. There you go.
There's got to be a reason for it. So, Yeah, I've done that before. I've had that exact situation with guys, and I would show them the math on what was going on inside of a thermostatic mix valve, and they said, "Yeah, but I like it the way I did it." Okay, your choice, man. So next time, try putting some air in that pipe instead.
Yeah, and let's see what happens. Yeah, I don't know. Those are those are things that, there are some people, and I'm not denigrating, because I'm one of those people that it takes me, you have to baff me upside the head several times with a 2x4 for me to understand things in many cases. It's just, some of us learn hard, okay? And I know that because I'm one of them. And the school of hard knocks is a harsh mistress and a very difficult school to go through. And sometimes you got to pay tuition to the school of hard knocks. I learned that phrase from Dan Foley, and I think it's one that applies in a lot of cases. If you don't want to learn the easy way, then you're going to learn the hard way. If you don't want to read the manual or listen to folks who know, that's okay. You figure it out for yourself, and sometimes that's the hard way. And the tuition to the school of hard knocks is very high. All right, it's very high, and your student loans are going to be long term. That's a darn good analogy. I just came up with that right now, right here
Oh
in
man.
this chair. Right, that's a good analogy, man. But you can't. If someone doesn't want to go with you, then they don't want to go with you, and you got to give them time to come around. Maybe they will. Maybe they'll get away with it. You can get away with an awful lot if expectations are low. Again, that's kind of how I've lived most of my life. Spend any amount of time with me, expectations are not high. So there we go. I'm using a delta P circulator as a system circulator on a highly zoned system. I can't quite see the benefit of delta T. A zone opens up and suddenly I see a delta T of 25 or 30 until it gets purged. Why the delta T recommendation? Because delta T, we're not worried about zones in particular, okay? If you got a whole bunch of zones and you got one delta T pump, just don't expect to see a 20-degree delta T in every single zone. That ain't gonna happen, all right? It's not. What we're trying to do here is make sure that the pump is running at a speed that's going to match the load at a given point in time. So say I got 7 zones, all right, and all 7 are calling. That pump's going to run at a speed that's going to maintain a 20-degree delta T for the boiler, all right, for the water going out to the system, between the water going out to the system and the water coming back. And it's going to change its speed based on the load, because GPM equals BTUH divided by delta T times 500. If I can keep that delta T as wide as I possibly can for as much of the heating season as I possibly can, well then, it's going to be of benefit to the system as a whole in terms of overall efficiency. It's going to impact short cycling. It's going to have an awful lot of benefits. Now, it's again, and we've got to keep in mind, we have a minimum speed on that pump. So even depending upon the overall load, you may find that you have most of that heating season with a fixed speed 9-watt pump. All right, that ain't bad either. It's a 9-watt pump, But delta T is going to vary its speed as not only as zones open and close, but it's also going to vary its speed as it gets warmer and colder out, because it's inferring load based on, how many BTUs are being taken out of the fluid. So it's going to run faster in January than it is in October or April. So in that respect, to me, it's the best pump on the market. Now, the difference, and this is something we've said a few times, the difference, the relative benefit depends upon the size of the system, all right? In some cases, in a really big system, the difference in performance between a delta T pump and a delta P pump is going to be considerable. Systems get smaller, the difference between the two is going to get a little smaller, to the point where maybe there's very little, if any, difference at all in terms of performance, and any performance benefit may not be worth the additional price you have to pay. That's why we also have the 0018E, an incredibly versatile pump where you have 9 different constant pressure settings for delta P rather than just 3, which doesn't really help you much. You are able to fine tune that pump to as close as the best as you can with any pump possible, We also have infinitely adjustable fixed speed, that blue mode that Rick was showing earlier. So if I need a boiler pump to do, what did you have there, Rick? Like 3 gallons a minute, or 8 gallons a minute at 4 feet ahead, or whatever it was?
10 at 5.
10 at 5. You can adjust the speed of that pump and look at your app, adjust the speed of that pump until bam, it's giving you 10 at 5.
Yeah.
And there ain't another pump that can do that.
Yeah.
So I don't know if that answers your question, Eric, but that's the answer. It's kind of the difference. Go ahead, Rick.
Well, I'm just when I looked at the question, I got something different from that. And again, I do the same thing. I'm probably missing it, and you nailed it. But I'm thinking about, he's talking about the time it took to realize it needed to speed up. And by all means, a Delta P pump will respond instantaneously. A Delta T pump will wait until it sees what that temperature differential is and then act accordingly. But one thing we've learned about hydronics, normally nothing needs to happen really fast unless it's domestic hot water, and that we're not using that control strategy in that application. So again, that's how I understood it. He was saying that he's waiting for it to get all purged out, but it drops the delta, right? The delta starts dropping, and it's taking a while to respond. So I don't know. That's the way I took the question.
Yeah, it's kind of like an internal filter, I think, for the pump. It doesn't want to say, oh, there's a change in delta D. A quick respond is, oh, a quick change respond again. The thing is, a Delta P pump is going to respond not based on BTUs, but based on open and close.
Yep.
It doesn't know how cold it is outside. It's going to run the same speed in October as it does in January, as it does in April. It's just the way it is. It doesn't know any different in a zone valve application, an on-off zone valve application. Let me know if that answers your question. That's some good stuff. That was a very, very good question. All right. Nature doesn't like a vacuum. Love you guys. Good night. Good night, Anthony. Always a pleasure. Always a pleasure. We love you too. All righty. I'd like to thank you all for all you guys have done with Takeo After Dark. The willingness of you three willing to stick around after and answer questions has been huge and means the world to us small shops. Thank you, Travis. Really appreciate that. I've had some webinars that quit right at the time it is done, even if there are questions. The three of you going above and beyond. Oh, we got to show this to our boss. Beyond is more than Travis, thank you. That's really kind of you to say. That's really, really kind of you to say. And thank you for taking the time to join us. I mean, we'd feel pretty silly here if nobody showed up and we were just talking, but thank you so much. That really means a lot. And it's really, you honor us by your presence. Thank you. Thank you so much. And Wes Cisco is in the house. And now he's finally saying hello. My brother from another mother, Wes. Now you're finally saying hello after all this. My goodness. Well, welcome, Mr. Cisco. All right.
Yes. Hey. Oh, never mind. I lost my train of thought. I started reading and lost my train of thought. So. Lots of questions. Cook.
Lots of questions.
What's Cook saying?
Let's see.
A whole bunch of stuff.
Oh boy, here we go.
Oh yeah, he's still talking about that mixing valve actually working. Hey, if the mixing valve feels a lower temperature than what it's calling for, it's going to start to open up. If it's got a pump on the other side, it's going to let some fluid through there, but that doesn't make it the right way to do it. That's why I said get everybody's drawings from the manufacturers, and they'll always show it on the mix side going out to the system. So you could put it on the return coming back from the system, 6 of one, half a dozen of the other, but still you're on the mix side of the system, not the hot side pumping into the valve. So again, we can beat this horse to death, but we shouldn't.
Right.
That's animal cruelty.
All right. Here we go. Here's a question from Jordan. Is it true that if an expansion tank is installed on the zone multi-pump side of a hydraulic separator buffer tank, not the boiler side, is that expansion tank hidden from the boiler, risking expansion tank related boiler issues? Example was on Rick's first buffer tank drawing. It's not a heat exchanger. It's just a tank, right? So either side to me makes sense, right?
Here's one argument. If somebody were to isolate the low loss header or the buffer tank, and now all of a sudden the expansion tank would be isolated, yeah. But how often are you going to do that? So, again, I showed you drawings from, years and years ago, and I showed you some new drawings. I think my new drawings would typically show the expansion tank on the boiler side, but
Mhm.
I think the worry or the hesitation would only be granted if somebody were to actually take and isolate
Right.
everything off and then let the boiler continue to run. I'll
Yeah,
tell
but
you, in my own experience, because I got PEX installed, I had my expansion tank shut off for 6 months during the heating season, and it never popped off, and it never gained any pressure even close to what my eye could see.
mm,
Guess why?
PEX expands.
Exactly.
There
My
you go.
PEX
Oh, it was
became
summer. Oh,
my
never mind.
expansion tank.
Well, we tell a story about a contractor up in the Rocky Mountains who all he does was slab on grade jobs, and he did by arithmetic. He proved he didn't need an expansion tank.
Yeah.
Because it was all slab on grade, so he didn't have to pressurize anything. All the piping was below his water heater. He used a water heater instead of a boiler, and the water temperature increase was so small that
Yeah.
the actual fluid expansion was more than handled by the expandability of the PEX. So he was quite proud of that. He waved at my face, says, "You wouldn't think I could have done this, man. I can do this. It says so right here. And I've been doing it forever." I said, "Well, that's awesome. Yeah, that's terrific. You don't need an expansion tank. How much does that save?" He goes, "About $40 a job." Excellent. Good. So yeah, a lot of things are doable. A lot of things are doable. Here's Mr. Riley with more of the story. Yeah, I said that with all due respect to those named Cletus. I said with all due respect, right, Ricky Bobby? From Matey, in primary secondary system, if the boiler pump is oversized, does it cause short cycling? Rick, I think we know the answer to that, but Rick, why don't you take that one?
Yeah, in the presentation, I was showing a close-up of the two closely spaced T's. And I was actually showing that the water from the boiler, if it's oversized, actually immediately short cycles and goes back into the return side, going back to the heat exchanger, thus warming the fluid on the return side, which is not a good thing.
Right. So, yep, I think that I hope that answers your question, Matey. All righty, here we go. Thank God its system is over. I can't seem to scroll
Here,
well.
ultimately, let me tell this because it goes back to all the ModCon people out there, right, that are buying ModCon boilers. To the best of my knowledge, there's not one on the market that does not, one way or another, tell you what the system delta T is. I shouldn't say it that way. The boiler delta T is, right? So when walk into any boiler room, if it's a cold day out, and you see delta T's at 3 degrees, 5 degrees, 4 degrees, 7 degrees, guess what? Your pump's oversized. There's no way to argue that, okay? What we're trying to do is get the biggest temperature differential under a design condition as possible. And the way to do that is under the initial circulator sizing, make it as small as allowed. And we do that by stretching that temperature differential out, right? We use that delta in our calculation that I showed you. If a boiler manufacturer will let you go to a 40, I would absolutely recommend that you use a 40 in that calculation. You will get a better performance long-term of that system.
Very good. Very good. All right, we got a long one here from Dan Cook. Shall we share this one?
The cook.
Lots of things in the hydronics world work that are not actually installed correctly. I grew up as an electrician where things sparked or burned when not installed properly, and my dad made me fix it on my own time. When I teach distributor classes at Weill McLean, I emphasize the finer details of proper installation of each component by talking about the instructions that come with each component. Instructions.
Yeah.
How unique. All right. I attend these seminars to pick up the finer details of circulators and motion pictures. You did not mention my favorite Western, The Good, the Bad, and the Ugly. Good, Bad, and the Ugly is a very good Western. I don't think it's Clint's best. It was, of the spaghetti Western trilogies, it was a very good one. But I'm a Pale Rider, Outlaw Josie Wales guy for Clint's Westerns, and you're not gonna move me off that. I'd say Good, Bad, and the Ugly's top 20 of Westerns, in my book, top 20. And my book's the one that matters. That's pretty much all we could say about that. But The Magnificent Seven, not only the best Western ever made, it is the best movie ever made. Bum, 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 da, da. Sorry. Da, 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 da. Great movie. Great soundtrack as well. All right. Any thoughts on when Takeo will run classes again in person back in the training room? Boy, that's a good question, Mark. I don't know.
Yeah.
We've canceled everything through July, just because we have our requirements in the state of Rhode Island and our own company requirements back at the factory. We have not canceled our fall schedule yet, and we hope we won't have to. But a lot's going to depend on what happens, and neither you nor I nor the man in the moon knows. Nobody has any idea what's going to happen here. We'd all, as much fun as these are, and these are a blast, I got to tell you. I'm sure these other guys will agree as well. It's nothing compared to being in a class together, spending a couple of days together, going out and socializing at night together, and having ourselves a hell of a good time. Nothing compares to that. And we would all love to be back doing that. As far as doing stuff out in the field, we had the same conversation. At some point, we're going to be able to travel. At what point would a wholesaler be willing to host 30 or 40 people in their facility? Or we could gather 20 or 30 or 40 people in a hotel function room. At being allowed to do it and then people willing to do it's a separate issue, So there's a lot of things that have to unravel. And I'm hopeful that we can get there someday. I really do, because, I mean, we've been housebound for how long, guys?
Well, 9 weeks.
Yeah.
10 weeks already. Yeah.
Yeah.
And how many guys want to hug the New Yorker?
Yeah. I want to hug anything, a high five, a handshake, anything like that would be nice,
Oh God.
I'm telling you.
It is crazy, man. I mean, my cousin came by today to help me out with some electrical stuff outside. And it was just like he pulled up and I just wanted to give him a handshake, and it was just hard not to. It's just whack, man. It's just crazy.
Yep. I got a little punchy this past week. This was the first week I started getting a little goofy around the house, and just kind of I honestly forgot what day it was for the first, for a couple of days I didn't know. And all of a sudden I woke up and it was Monday morning, and I said, what the hell do I have to do? It's Monday. What do I have to do Monday? And all of a sudden it was like, oh God, I had like 4 presentations to put together, and it's like, uh-oh. And this is the first week I've completely lost track of what day it is, what time it is, and where the hell I am, So that has not been artificially induced, let's put it that way,
Yeah. So that picture from earlier on Here's Johnny, that was true this week then.
Yes. He's a little punchy, just a little punchy, All righty. What else do we have here? We got Burnham K2 doesn't give that info in the manual, says Eric Miller. Let's see, Wes, I thought I was at a meeting at Upanor. No, it was Worsbo. That's where we worked. We worked at Worsbo, right? There you go. Now, Wes, I you got a lot of guys know Wes. Wes was again another Worsbo guy. A lot of really good people in this industry made their bones at Worsbo and then moved on, and it was a great place to work for the time we were there, and it's a great place to be from. And then, we all grew up. Most of us grew up and moved to Takeo. All righty. Mike Hansen, see every week.
Good. I mean, there's still some good peeps out there. And,
oh gosh, yes.
Oh yeah, so no animosity between
none at all
of this stuff. So yeah, it was just something different to do now. So yeah.
I miss Jeff Wiedemann to this day. This guy that just had so much going on, and just a smart dude, and really was he's carved out a great life for himself, and he's been there. Ingrid is still there, and everybody who's ever met Ingrid is madly in love with her. She's just wonderful, and there aren't a whole lot of people left there from our day, but we put that place on the map, and these folks taking it to the next level. So that's it's kind of a good feeling. All righty. What else you got out there, folks? We're down to 94 of you. So Bruce Blomfield signing off. Thank you, Bruce. Appreciate you being with us. Yeah, let's keep this going. As long as you guys have questions, we'll hang. So whatever you have for questions, we can vamp as long as you want. I mean, I'm sure you've picked up on that over the last 8 weeks that
Yep.
the three of us talking's not a difficult thing.
Looks like Rick still has some Mayorita there, and I'm still going. So
I'm
Scott
sucking on
Hellinger.
ice.
Scott's an old Upanorian too, right?
Absolute.
That's another one.
Worspo boy.
Mr. Hellendrung, a glass of water with you, sir. And it was just water too, Poland Spring, good stuff.
okay.
And it was sparkling water too, sparkling Poland Spring with a hint of lime.
Oh my, the lights went
What's
out.
with the cutaway golf ball? Oh, this thing? Yeah, I like cutting golf balls in half, just to see what's inside. Is that weird? I don't know.
What happened to the rubber bands?
Well, those haven't been in golf balls since the 90s.
Neither have I.
There you go. Everything's solid core now. Okay, this is a 4-piece solid core cast urethane ball with this is a Penfold. It's a kind of an off-brand Penfold dual ID. What else do I have? I got a Wilson staff, a new Wilson staff model, and you can see the inside. It's a 4-piecer as well. Here's a 2-piece. I think that's a 3-piece. That's a 3-piece ball right there. So, what did I shoot last week? I shot a lot. I'm in spring training, and I'm telling you what, if I grew tomatoes, they'd come up sliced. Okay, let's put it that way. All right. Here's one. How to take a website to size a pump and impeller. Now I'm not sure for a non-rep how they go about doing that. I think you can use there's
Pump sizing tools
selector
available to anybody.
Right, we do have pump selector tools that you can
Yep.
download, a whole suite of apps and programs that you can download that can certainly help you do all that, Ferris. So yeah,
Right on the website, guys. Right.
Yep.
Go to the website and they don't have to have an app or anything. So
Right.
Right.
There you go.
It'll get you into the range of circ that you're looking for. And then if the impeller needs to be designed for that particular application that you're looking at, then they'll go from there.
Dan Cook says, no, not weird, but just read the box if you want to know what's inside. Yeah, but this is more fun. All right, I've got a pipe cutter. I got to be able to use it. But also, you'd be amazed how often, Dan, cores are not centered.
Really?
And how you might have a
wobble.
A wobble, yeah. Balls, there's a lot of inconsistencies in ball construction.
You got one?
I got 2.
Hey,
this
now.
one,
And
No,
there's
this
some
one's pretty good.
inconsistency in those as well.
yeah. You may see. Now this one's all pretty thin, but sometimes you'll see. The cover being of different thicknesses. All right. You see the cover of different thicknesses, so it's not consistent all the way around. So it's not, if it slices, it might not be you. It might be the ball. So there you go.
Damn.
And
That's
why are
what's
there
happening.
dimples on the outside? Because if you put the dimples on the inside, no one can see them.
Yeah.
Dimples give you trajectory and aerodynamics. Different dimple depths. The deeper the dimple, the shallower the flight. The shallower the dimple, the higher the flight. So there you go.
Jordan's got a good question about indirects.
We're talking about dimples.
Who cares about dimples or
Yeah, I
golf?
know. All of a sudden, hey, we're talking golf here, brother. I
Hey,
don't know.
what's going on
Golf
here?
doesn't
Well,
do golf.
I'm
That's
back to
why.
business.
Back to business.
We got to
All
get
right.
him in a golf course one
Jordan,
day.
I'll
Hey,
go sit in the
Jordan.
corner. I'm in. Time out.
Jordan, just the manufacturers that make the indirect tanks will show you which way they want the flow to go. There is a difference. Sometimes it's just a slight difference depending on the velocity of the water going through the pipe, but they typically want you to pipe it a certain way. So look at what the manual says. Sometimes it's going in the bottom hole, sometimes it's the top. And again, just check what the manufacturer says. Ultimately, what they want to get is a counterflow arrangement. So if the cold water's coming in the bottom and running up, then they'll want the pipe that's at the top supplying and crossing that flow. So just look and see what the manual says. Typically, they want counterflow.
Why don't you guys handle the next question since I'm in a timeout?
No, you're not in a timeout.
Oh, I was trying to give him a timeout, meaning Rick. No, we were talking golf here.
I
know.
I thought I was out.
No. I was trying to kick Rick out, but he just kept on talking. So.
All right. Well, Rick's back to business.
I'm usually the last to be talking. What do you mean?
No, Rick's clearly the adult in the room here. All right.
No.
Antonio Marte, what's your favorite way of making sure a 007 is actually running? Sometimes the low amperage reading can be deceiving on some meters. Do you recommend that little magnet keychain thingy, boys? Nope, we got not shaking heads here, Dave.
Well, go ahead, Dave.
Well, one, the little keychain thingy's not going to work on a 007 just because of the placement of the motor itself compared to the end of the cartridge, so of the motor housing. So it's hard to get any of that. All it's reading is electromagnetic field. It's not telling you anything is spinning whatsoever. Now, if the motor's burnt out, then yeah, that magnet thingy's not going to work. But all that does is read a little magnetic field that is created, and every motor creates a magnetic field. Whether something's spinning or turning on the inside is completely irrelevant to the magnet. So, what's the favorite way? Hey, grab the pipe.
Yeah.
Feel the pipe, and if not close, you got to get a little further away from it. And if it's cold over there, then nothing's moving. So.
My uncle, and I still to this day don't know if he's crazy or not. He used to take a screwdriver, put the thick end up to his ear, and put the flat end on the motor. And if he could feel it, because they're so quiet anyway, if he could feel it vibrating, feel like the kind of thing, then he'd know it was running. But that's my uncle. My uncle also told me his finger got bit off by a horse too. So I don't know what the truth is there.
I mean, if you've got isolation around the circulator itself, if you don't know what the hell's going on, pop the 4 bolts out, look at the motor, turn it on, give it power, and see if it spins. Mm-hmm. That's usually the best way,
Yeah. What happens if the buffer tank is installed horizontally?
I'm answering that right now.
Oh, okay. My first, it'll take up a lot more floor space that way.
Yeah. The stratification that we're looking for is greatly reduced, so it's not typically not a good thing. Hence my little short, if it's just a little tiny thing, it could be short. If it's a bigger tank, it should be tall.
There you go.
Yeah.
Very good. Carlton, your doorman is signing off.
Yeah.
Carlton Pember, thank you. Carlton, good to see you. Thanks, and have a good night yourself. We're down to 8. There's still 81 people out there. Do you believe that? 81 folks still out there hanging. It's 9:15. Don't you people have lives? Because we sure as heck don't. So glad you're here.
This is our life, yeah.
This is our life, such as it is. We're talking about horizontal buffer tanks and cores in golf balls.
And how come there's no dimples on the inside?
How come there's no dimples on the inside? Right. I mean, you put dimples on, we can see them, man. It's like, why is there air? It's the same thing. How many of the Taco pumps have the hex spot on the pump body to make putting flanges on a single tool install? Oh, okay. How many have that? The nut grabber, right?
Yeah.
The nut grabber. Well, all of the ECM circulators have a milled nut grabber on them, which is terrific. I mean, again, it makes putting those things together so much easier. We have Freedom flanges, and flanges have the nut grabber built in. I think the standard 007, however, do not have the nut grabbers. So you'll find it on the circulators on the high efficiency, the new ECM 00E series pumps. Other ones are Freedom flanges have nut grabbers built in, so that hopefully that'll help you. All right, very good. How about checking pipe temps above and below the pump to determine whether it's running? Novel concept. Yep, that's it.
Yeah. Just
You know?
grab it. Yeah.
Yeah.
I do it the old-fashioned way. Grab it with your hand, but back of your hand in case it's really hot.
Yeah. And the funny thing you said about, one way to tell if you have a burnt out motor is put that little magnet thingy on it. If it's not spinning, it tells you it's burnt out. Well, so does the fact that it's not pumping anything.
Yeah.
It is another really good way of telling. Yeah.
Yeah. Why are we here? Yeah.
Yes. Yeah. Again, guys, a lot of this stuff's a lot simpler than it's made out to be. It's just, you can
Turns
really
out to
get into the finer points of crazy stuff, but all of a sudden we're making water go round and round and making heat. We're not flying
Yeah.
this thing to Mars.
And it doesn't take long for the water to get hot on the other side of the circulator. I mean, seconds.
Mm-hmm.
So, I mean, when we think about it, we've been throwing out these numbers exhaustively throughout these seminars, meaning gallons per minute or feet per second.
Yeah.
Stop and think about that for a second.
Mm-hmm.
We're looking at 2 to 4 feet per second.
Yeah.
Boom. All right, we're over
Yeah.
there. 3 feet. Done. In 1 second.
Yeah.
So it should not take long for something to get hot a foot away, 12 inches away. It should heat up quickly. So that could help us think about, what's going on in there. I learned this from Dan Holohan a bunch of years ago. He said it at one of his seminars, and in trying to troubleshoot a system, when you're standing there staring at the boiler room, think like a marble. And you put marbles into the pipe. And imagine marbles sitting in there. Now, these are magic marbles because they actually change size as they go to a different pipe. But think about as those marbles are moving through a system, as you're imagining where they can go and what makes them go. And the only thing that's making them move around is the circulator itself. So if you want to try to troubleshoot systems, think like marbles. And the pipe is completely filled with marbles, and they're all touching each other. There's no space in between them. And if you have, say, 1 1/4 inch header and it tees off to 3/4, then when it goes to 3/4 inch pipe, the marble magically shrinks, but they're all touching each other. So that made me think about systems when I would go to job sites and troubleshoot and take a look at them. You got to think about where the marbles are moving around the system itself. So that helped me also too.
Very good. Very good. I'm gonna refrain from any lost your marbles jokes at this point because that was really impressive. Really well done.
And that was half the 2 drinks too. Yeah.
Yeah, there you go. Does using a buffer tank affect a mod-con's efficiency? Does a mod-con efficiency change as it modulates? Rick?
Part load efficiency, yes. The smaller the ratio, or let's say it this way, the higher the ratio between the heat exchanger surface area, which is fixed, right? We don't have a modulating heat exchanger. We have a modulating flame. So as the heat exchanger size is a big difference or a big ratio with a flame size, there's actually a slightly better thermal efficiency. And those, you can actually look those up in what's called part load efficiency curves. So you can look those up anytime you want. Whatever boiler manufacturer is your fave.
Very good. There you go. There you go. Another fine presentation from the Delta Tau Chi house. There you go. All right. And your Delta Tau Chi name is Pinto or Flounder. 2 of my favorites. Brother D-Day was a good one too. I liked him. Daniel Simpson Day has no grade point average. All classes incomplete. All right.
Dan's
Bill
going for ice
D'Agostino. Say what?
Dan's going for ice cream.
Dan's going
He's
for
outta
ice
here.
cream. What kind of
Yep.
ice cream you gonna get there, man?
He might have been
Yeah.
gone already.
Like I said, I learned a bunch about hydronics, golf balls, and marbles this evening. Time for ice cream.
Quite a variety.
Joe Finelli's out of wine, so he's gonna sign off. Very good. All right.
Mint
Yeah,
chip,
you go.
Dan said.
The ice cream shop. I don't know if that. I know who. I'm running a blank right now on the ice cream shop out there, so that he might be running too.
There you go. There
Yeah.
you go. Peter DeMeo, who's no relation to Rick DeMeo, Thank you so much, guys. Say hi to Wes for me. All right. Thank you. Bubbles in
Bubbles.
Michigan City. Bubbles.
Yes.
Bubbles
Yes,
Ice
yes,
Cream Shop. All right.
Yeah. I got to
All
get
right,
there. I have sampled it, but I've got to get to the store. Yes, I got to get to that place.
Was it over when the Germans bombed Pearl Harbor? Forget it. He's rolling, says Wes. Yes.
Yeah.
Well, it's almost over here. It's almost over. We're down to 68. Was it over when the Germans bombed Pearl Harbor? Mr. Messenbrink, are you still with us? Are you going to keep all of this fun stuff in the recording that you post on YouTube, or are you going to shorten it up a little bit? Because this is what happened. I tell you, punchy, just punchy. That's where we're at. I'm a punchy guy right now.
Bunch
Mr. Messenbrink left us already.
Mr. Yeah, he says, I've had enough of this.
He's
I don't want to
gone,
be
yeah.
associated with this debacle.
well, his name's all over it. So
Yeah, he's probably saying, you know, guys, 8 sessions is fine. You're good. You're good. Oh, hey, they have great tie-dye T-shirts. Let's go there next time. I'm all. Let's all go to Michigan City. Dan, you're buying at Bubbles. All right. Good. Well, good. You know what I had the other day? Bought it at the local grocery store, was avocado ice cream. It's made out of avocados. Yeah.
Really?
yeah,
Avocado ice cream. It wasn't horrible.
Now, but because you haven't had ice cream.
I haven't had ice cream for a while, right?
That's right. Okay.
So I'm not full vegan. I'm cheese, eggs are okay.
Okay,
right.
I got you.
Cheese and eggs are fine, but no milk. You know, we're doing almond milk and stuff. But that's just kind of where we're at. And haven't had meat since before Thanksgiving. So.
Well, okay.
yeah. Nothing
Although
with eyeballs.
I did have a Cobb salad when we were at the Marriott in Providence that had bacon chunks in it. I survived.
Did you repent?
Did I repent?
Yeah.
I didn't pent in the first place. How could I repent?
Okay. Catholic boy.
Yeah, there you go. I know.
All
I'm gonna turn it back to work for a second. Jordan asked another question, kind of unrelated, but hey, this is what the night's about. But looking at cleaning up the wiring, and I've got a good tip on that. It does depend on the space that you have available, but when I first got involved in the industry, I worked with a contractor that most of his boiler room walls was about 2 feet off of the concrete wall in the basement itself. He would have a studded wall built and plywooded out, and he would knock all his wires through the back of the SR and ZVC panels. So he would punch his own holes in it, so you didn't see the connectors come out the bottom and then go into the wall. All the wiring went behind the walls. And I've done that in my own home too. And just to really neaten up the wiring, you don't see any wires. He would also use Badera's cast iron boilers at the time, where all the piping came out of the back of the boiler.
Mm-hmm.
So in this boiler room, when you walked in there, all you saw was the boiler, an indirect, a couple of controls on the wall, and a can of wax for the boiler. And it was a beautiful thing. Now you went behind that wall and it was scary because that's where all the pipes and the pumps and control, but the controls were on the front side of it for the, diagnostics and whatnot. But that was a really big thing that I learned, is try to really neaten it up. Hey, hide it, make it go away. And just get rid of it. The homeowners don't want to, so to speak, see our artwork.
Right.
For us, it's artwork. For us, for homeowners, it's scary.
Yeah.
So
it's kind of like it's like a computer. All you want to see was on the screen. You don't want to see what's behind the screen or inside the computer. It's on a case. You don't need to see that crap.
Yeah. So I like to hide as much as I can in a system. So and put it behind the wall so nobody knows what's there, and it looks better for the customers.
There you go. Yeah. Eric Miller says he's got to go. I should let you know that even my wife got a kick out of you guys this evening. Well, I'm glad she enjoyed the show. Tell Mrs. Miller we're very pleased, and we do parties, bar mitzvahs, graduation. We make us an offer. We'll go anywhere. We're fine. This is our road show is actually quite good. A little risque. Be careful who you invite, but yeah, we're okay. Rick does his impressions, Dave does balloon animals, and and I sing I sing the songs, I get the girls, I'm Dean Martin, I got 2 Jerry Lewises, let's put it that way.
George Clooney. Yeah, I know.
Yeah, George Clooney. It happened again today. A woman came up to me, says, George Clooney? I said, no, I get that all the time,
Yeah. Except the only woman that you saw today was Heidi.
Well,
because you didn't leave the house.
Yeah, I know. She does humor me. She does. She's a good woman. She indulges
you, right?
She indulges my little, alternate reality. So it works out. All righty. Hey, well, we're down to 58, and let's do a last go round for questions, guys. Any last minute questions you have? Let's do it. Otherwise, we're gonna flip all the cards and say we'll see you next week at part 9, and we'll figure out by next week we'll know how far we want to go with this, and maybe after that it won't be a series, it'll just be a bunch of individuals, but we'll want to hear from y'all and see what you want. So thank you all. Good night, everybody. Wes, mwah. Love you, brother. Hope to see you soon. All right. Take care, everybody.
Good night, y'all.
Good night.